Hello, everybody. Welcome to another stream. It's another one. We did it. Was that a YouTuber worthy intro?
Sure.
It was. We got a sign of approval from the wonderful and generous Saraid, who is joining us once again. Better known as Eternal. Or Eternal? Is it just Eternal? Eternal?
It's just like the word.
It's just like the word eternal.
Mm-hmm.
Okay.
The reason it's spelled the way it is because it used to be spelled that way, or at least because the Latin word it comes from is spelled that way, more or less, without the accent, of course. But actually, I'm not sure about the accent. I don't think the E is long in Latin. I'd have to check.
Long E's.
It
Anyways.
does not appear to be long. Anyway.
Nice. You got that answer fast.
I just looked up the word, yeah.
You got good Google foo.
Well, it's Wiktionary in this case, but yes.
We're going to be working on code gen a lot today on the compiler. Doing LVALUES.
Yeah, this is going to be fun.
That's my favorite. I love changing entire systems of the compiler and, going through like hundreds of lines of code and fixing it.
Yeah.
So yeah, we're just gonna get right into it today. I don't think there's honestly, I don't have time to play around.
You didn't announce it on the Discord, did you?
Oh, I
No,
didn't. You are the best.
You didn't.
Click.
We saw that there was no notification, so.
That's why you're here. That's why you're here. Anyway, yeah, good time to mention the Discord. It is in the About section if you're on mobile, and if you're on Discord, if you're on Twitch desktop, then you can just. That's right. Then you could just scroll down, and this link will be here. There's a permanent invite link, and you can get help with code, talk about anything you want in off topic, or get help with code in off topic, as people seem to like to use it for. And off topic can also be about code, I guess, arguably.
Yeah, I think I posted like a C++ thing earlier in the like some.
I see.
Is this valid C++? The
Emacs has an Android port, and it's going very well. So when in the init file I have global auto revert mode 1, the device vibrates.
No idea what global auto revert mode is.
Basically, a global prefix like this to a mode means that it's a minor mode, but it'll be enabled in all buffers all the time, like a major mode. And then auto revert mode is so that if another program or process changes a file while you're looking at it, it'll revert.
Oh, I see. It reverts the buffer. That makes sense.
And that causes it to vibrate. Which I just love. I can just imagine you just open Emacs and
reminds me of that one XKCD. Let me see if I can find it.
There's always an XKCD.
Yeah, that is always a relevant XKCD. That is true.
So can we do if L value emitted, or do we may want to emit both so this doesn't work anymore? Do we have to?
So for this, why is emitted a thing? Do you ever set emitted to false?
What?
Do we ever assign false to emitted?
Nodes are calicked, I believe.
Yeah, but except for that, apart from that, do we ever set it to false?
No, definitely not.
Okay, then it's pretty useless actually, because we can just check if the instruction is not null, right? Actually,
not everything.
Not always, because there's some things that return void. That is true.
Yeah.
So I suppose for L values, we should be able to check that if we put the L value in the, and if it's emitted, I see now what you're asking, whether that should also. I don't think that should check this like for L values, because L values always have an address, right? They always have a value, so we can just check if the struct field that holds the address is non-null, and if it is non-null, we emit it, otherwise we don't. Null.
That's
and if
right.
it is non-null, if it is null, we emit it, otherwise we don't.
And I think I found the XKCD.
Nice. So it's just, there might be a background noise there. I was checking to make sure that we could hear myself and you. I'm gonna close that now.
I was checking the stream, and I think they can hear us, so yeah.
That's good. That's good. That's always a good sign. Also, someone asked, who are you in a call with, by the way? Also, hi. At the beginning of the stream, we mentioned it, but I am in the call with Surreyed/Eternal.
Mm-hmm.
And yes, spelled with one R on Twitch because it was taken.
I don't remember why I spelled it with one R, but that's
spelled with one R on Twitch because unicorns.
Put the XKCD in off topic in case you haven't seen it yet.
Nice. I didn't. I missed it. Oh, okay. Longtime user 4 writes, this update broke my workflow. My control key is hard to reach, so I hold spacebar instead, and I configured Emacs to interpret a rapid temperature rise as control. Admin writes, that's horrifying. Longtime user 4 writes, look, my setup works for me. Just add an option to re-enable spacebar heating. This is all in response to changes in version 10.17. The CPU no longer overheats when you hold down spacebar. Oh, God.
Mm-hmm.
My phone rang. Someone called me from Ohio. I'm screening the call. I love that feature of the modern world where you can just have a robot answer. Also, this is really accurate. If you're looking at the tree sitter debate right now, this is basically what it is. When it comes down to it, that's it.
Mm.
Spacebar heating. Let's see now what we don't have VSync and LensOS.
Yeah. Yeah. VSync and LensOS is basically because OS Dev recommended that for some reason.
No VSync? Jesus Christ, that's horrifying.
No, they recommended VSync at the kernel level. Like anything you draw is buffered at the kernel level. But then if you write a user space driver, and then you're trying to draw to the frame buffer, if that's double buffered and then you double buffer that, that's a lot of buffers and copying for no reason. So there does have to be like a kernel API that just operates on the actual frame buffer.
But yeah, currently we don't have VSync.
Who needs that, really?
Oh, you should hear my poor seat, my poor GPU. The fan just spins up like crazy. Look, I can hear that there is no VSync.
Zarias, Max, hello everybody. Thank you so much for tuning in. I appreciate you commenting, making messages. I love to see people stopping by.
So I think the first thing we need to do is add an address or whatever we want to call it to the instruction struct.
That's probably a good thing to do. That way we know where to put this answer.
At least we're not talking about structs anymore, because like implementing structs, that's like so we need a struct to hold the struct, and a type struct holds a struct, a type of type struct. That is it's horrible.
At least it has a name.
Yeah, at least this is easy to talk about.
So probably here.
Yeah, somewhere in the probably. Actually, no, wrong, incorrect. It has to go in the node, not in the instruction. Sorry, the node has two instructions now, and rest in the value.
Okay, that makes a lot more sense.
Yeah,
than what I was thinking.
I don't know why I said instruction.
Okay, so the AST.
There we go.
Am I here? Am I in it? I am in it.
Yeah, right. Below the event.
So we're going to have IR and address. I think this is fine.
Mm-hmm.
And then we're going to say things that are L values store their address here.
Yeah.
Okay. Max asks, is int fast as C? It's faster than the worst C you can write.
I suppose so, yeah.
Because I could write some pretty slow C. And in that case, intercept, oh yeah, faster. But overall, I'd say the code looks similar to like GCC without optimization.
Mm-hmm.
And
Something like that, yeah.
With optimizations, there's still some very clear things that we need to clean up before it even starts to... I think Saraid can talk on optimizations better too.
Could be, I mean, it is pretty similar to GCC without optimization. Like GCC without optimization has like no register allocation at all, pretty much. So we might even be a bit better in that regard. But
that's true.
And then again, it's code, it's unoptimized code. So comparing that is, yeah, the compilers will just emit everything, literally copy every parameter into a variable, etc., just because that's the literal meaning of the code. Oh, that's a long
Banhammer.
Ah, yes. Brilliant. I just saw that, like, I wasn't looking at the chat and they just sort of pop off and then like, oh god, that's a long. Jeez. But yeah, and in ESC you can also probably just delete something from the buffer, can't you?
Can I? I don't know how, to be honest.
I don't know.
No, it's read only by default.
Oh, it's read only. I see. Because I recall being able to.
You can toggle.
Oh, I think that was that in SBC. I think it was in like Slime, like the Emacs mode / subsystem, whatever, for common Lisp, where you can just delete stuff out of the REPL. It was really fast.
That's crazy. But yeah, so this is T by default.
I see. Okay.
ERC read-only mode. We added we don't need to be here. We added an address to a node, an AST node, because an L value may contain, we basically need to reference more than one thing. Okay, we can do this now. Does that make sense?
Sorry, can you say that again? I was looking at someone else for a second.
That is okay. I do the same thing. We basically are adding into the AST node, each node, instead of just having one instruction that is referenced to it that just contains its address, it now has one that will reference its address, and this will now contain like the value. So this will be like the how we store L values, because L values are effectively just value plus address.
Pretty much, yeah. And the way these two interact is, in order to emit the value, like if the thing has an address, then address will be set and we emit it, and to emit the value we also need to emit the address. So for cogening things that are L values, the way we cogem them is that cogen L value will just emit the address, and then cogen expression will call cogen L value, and then a load if it wants to emit the value, or just cogen L value if you don't want the address.
Beautifully said.
Well, not quite.
Done.
Also, we need to check for if lval address instead of lval emitted.
Thank you. So if this node already has its address set, then don't try and set its address again.
And in here, we basically need to do the same thing as in cogen expression. We need to switch on every node kind that could be an L value and emit that.
We have a great question from chat, from Max. Wait, what is L values? Okay, let's do this. We're going down the rabbit hole. So I kind of had the same question. So L value example .int. And basically, the terminology originates from like old C, right?
It might even be in B. Like I think it's possibly even older than.
So it's like, it might be CPL, BCPL, it was way back.
Yeah.
Way back. And basically, in the compiler, they realized that something on the left-hand side of an assignment, so in C, it would be like A equals 42, right?
Sure,
So,
yeah. That declaration in C, that's not the best example. Perhaps A equals 42 is a better example.
Int A equals 42.
An expression in C.
Yeah, this is better. So with A equals 42, you can see that it's on the left-hand side of this assignment. Whereas if we then do int B equals A, you can see that here it produces an int. Whereas here, the value of A doesn't need to be known. We just need to know the address of A, aka where it's stored in memory. We don't need to know the value at that memory address. So in this case, it's on the left-hand side, but it's still a value. So it's like a thing on the left with a value. That's literally the origin of the name, left-hand side value.
Pretty much, yeah. So an L value, it conceptually or informally, so to say, an L value may appear on the left-hand side of an assignment, or actually an L value may appear on the left or the right-hand side of an assignment, whereas an R value can only appear on the right-hand side of an assignment. And in A is also an L value in the case below. It's just used like an R value, but A itself is still an R value.
That's actually...
C++, you would call this L value to R value conversion. What happens here when you do B equals A?
Exactly.
A is an L value, but it can be used on the right-hand side.
Yeah.
Whereas an R value can only be used.
So every L value equals an R value. It contains one. Whereas every R value does not equal an L value.
Okay, perhaps a better way to think about
it's
this.
It's like a rectangle.
With left-hand side and right-hand side, that works. But another way to explain it is also that L value, even though it's called L and R value, the L doesn't originally stand for left-hand side. It stands for locator value. And that's because an L value is something that has an address in memory. So I think the easy way to explain this is A equals 42 is valid, but 42 equals A is not. Because A is a thing in memory that you can assign to. 42 is not. It's a number. You can't change the value because to assign something to a variable means store something in memory. 42 is a constant. It doesn't need to exist in memory, whereas A as a variable does. So an L value is something that has a location in memory, typically a variable or a dereference pointer, whereas an R value is a temporary, something that doesn't have a location in memory. And yet another definition would be an L value is something that persists across multiple expressions, whereas an R value is a temporary. It persists only in it doesn't persist, it exists only in the expression in which it's used. Yeah,
it means a lot of things.
Address of is also a good indicator. You can only take the address of L value. Address of 42 is nonsense because 42 doesn't have an address, it's a constant.
Whereas the address of A makes sense, as that's an int pointer.
Yeah.
Beautiful. Hope that helps.
This is like the traditional notion of L values. In C++, it's a lot more complicated than just L values and R values, but we'll leave it at that.
So in in intercept, we have a very similar thing because we also have assignments, basically. And now that we have structs, it gets kind of complicated. Because as soon as we have like some vec2, which is a vec2, and then we have some vec2.x is assigned to 42. This is an L value now. So member accesses can be L values, and so can array dereference, pointer dereferences, basically.
And with member accesses, it's Double important the way that code gen, because a struct can be very large, but we don't want to load it at all, but we especially don't want to load the entire struct just to store into a single member. And even if we use it as even if we need the value, we don't want to load the entire struct. We only want to load part of it. So we need to actually compute an offset and then load that.
Which is
We don't want
basically
to
a crazy
load some
subscript.
vec and copy it out X. We only want to load X out of some vec.
Exactly. Anyway, that's what we're working on. So the first thing that we should probably do is set this to something non-null.
No, because we don't know what this is yet. This is going to be an instruction that's emitted. We can't set that immediately. Because depending on the node, that will be different.
Okay, that's a good point. I was just going to set it non-null so we don't infinitely loop.
That shouldn't really happen. I don't think, like...
Famous last words.
...in an AST too well. Like, that would be a very weird if you somehow manage that. Or as you would call it, a DAG, a directed acyclic graph.
That's right. That's what it is.
We should never go back to this because it doesn't have cycles. Can't emit it again while emitting itself. Or at least that shouldn't happen. Anyway, yeah. Unhandled node type and codegen L value. And that can be an ICE because we should already be checking for L values in SEMA. So if something gets into here that's not an L value, then that's an error in SEMA and not here.
We should have like a way to print the kind as well, eventually.
Yeah, the kind is just a number currently.
Yeah.
Also, maybe don't print node type because node type typically refers to the node kind. This is like data type, basically.
Uno momento. So what do you said that don't print the type. It doesn't make any sense. Print the kind.
Either don't print the type or just print the node kind, yeah. Or at least if you're printing the type, don't call it node. Because it's the data
I see what
type
you're saying.
Node, not the kind of the node.
Yes.
Anyway, so we can straight start by deleting everything that's not an L value.
Well, I was going to actually say this is not an L value and have a specific ICE. That way it's all kind of explicitly handled, right?
I mean, we can just do it. Yeah, the default ICE says, okay, that's not an L value or unhandled because for whatever reason.
Yeah, it would just be a more specific, like, we already know this is incorrect versus you may have created a new node type that we don't know about. But it's probably not needed for now. You're right.
It should be handled in SEMA, not here.
Yeah.
That would have been caught in SEMA, shouldn't you?
I hope that we never have a root.
Yeah, a root is not an L value. Function is also not an L value. Declaration can be an L.
Well, it can be. That's a good point. Yes.
I suppose for an if, what we could do it is an L value if both its else and then branches are L values.
To do
that's the general rule for ifs. If it is not void and if we can emit the else and then branch, and if both of them are set, then sure, maybe. But if is not that important. We can get back to this later.
So then what I'll do is this.
Blocks.
I don't know about that one, dog.
That one is weird.
Max says the int syntax is cool. I like the thing. We were joking about that.
It's, what did you call it?
The
It's
thing operator.
The arrow thing or whatever you called it. Yeah, that's it. That's the official name. It's the thing operator. Anyway,
this makes a thing.
Yeah.
Is a ternary
operation, and a ternary is a ternary, an R value or an L value. Depends on the language. In C++, a ternary can be an L value. I'm pretty sure in C it isn't, or the other way around. I'm pretty sure in C++ it can be an L value. So you can do
forgetting how this works.
like that, yeah.
1B A is
And
42.
then you'd have to wrap in C++. If you're talking C++, then you have to wrap the entire thing. And yeah, but I think it's valid C++. But invalid C or the other way around. So it depends on the language if you really want to deal with that. And that would be basically how we work for an if, because the ternary is just an if.
You can also use the type inference syntax eventually. This isn't implemented right now, I don't think. Oh, sorry, I'm
not
answering
sure if
chat.
inference inside of a struct declaration is the best of ideas always. Because I feel like in a struct declaration, you want to be explicit about what you want this to be.
I agree.
It's the same with how we don't allow type inference in function parameters.
Exactly. Because this is a declaration versus a definition. Whereas when we're making a vec2, we do plan on making a struct literal syntax where we can do x equals 42, y equals 69, or we can even do some other vec2, and you don't actually need the names if you're putting them in order.
Mm-hmm.
That's the hope.
That makes sense. It's just like in C++, basically.
Yeah.
Can you make a function in a struct? No, I don't think we can't do. Someone's asking that. We can't do that currently, and I'm not sure we want to.
I can hear Thraid's deliberation because he knows there's about to be a whole thing from me. So, listen. I'm not sure if member functions made things better.
They're pretty pointless, I'd say.
I think the idea that C had, where you define a struct and then define an API that operates either on or around that struct, is a good programming mentality, and it works. Whereas, go ahead.
Go ahead.
I was going to say, whereas when you encapsulate the logic with the data, you get this really messy thing where all of a sudden none of it, like nothing can be separated out anymore. Everything's all this self-contained thing, and it must have everything, and you can't like...
There's, I think, two things I'd like to mention. That first, the thing you mentioned with everything together, I agree that classes, the way they're implemented in C++, for instance, are a bit stupid in that they're an agglomeration of unrelated features. Like you have object concatenation, basically. But also in the form of member functions, you have a sort of with statement that just pulls all the members into the current scope.
Oh, no.
You have constructors and destructors that are also on there. I guess that has something to do with structs intrinsically, but it's like kind of several unrelated things that are linked together, and you can't just have one or the other. You can't just concatenate structs or just pull everything into the current scope. It's always together for some reason. So that's the thing you mentioned, where it's, or at least what comes to mind when you say everything is together where it doesn't have to be. That's one thing. And the other is that with encapsulation and things like private members, private members in C++ aren't really private in that you can still access them if you just do the offset calculations manually. Of course, it's technically UB, but who cares? You can. It's explicitly said in the standard that you can read or write to anything as a char pointer, so you can just read it out as a char pointer and get the value of a private field. It's not easy, but you can do it. And it's like this weird thing where the compiler hides or attempts to hide something for you or makes it undefined, more or less, where a member is in the struct, even though it's a low-level systems language. It's like the same way how Go says that the size of a struct is undefined, which is like for a natively compiled language, it's a bit of it's a very weird thing to do. And the thing about encapsulation, I feel like, is also that a lot of people don't understand what encapsulation means. Because if you have a field called foo and you have a get foo and a set foo, then that's not encapsulation. Because you can still get and set the value. It's just more complicated. That has nothing to do with encapsulation.
That's a good point.
Encapsulation
That probably wasn't the best
you can't access it at all. Like encapsulation is not, okay, I
It's
get
black
the foo,
boxing.
I do something with it, and then I set the foo. Encapsulation is I call a function on the object, do something, and the do something ends up modifying the foo. That's encapsulation. Get foo, set foo, get this and that are not encapsulation. They have nothing to do with encapsulation. But people call them encapsulation for some ungodly reason, just like people call everything OOP, even though it has nothing to do with OOP. You can have a function pointer, yeah, but that's going to be inefficient, just actually how virtual calls are inefficient, yeah.
So I did want to point out, you can kind of hack the system a little bit.
You can have a function pointer in a struct, sure. Just like in C, you can do that.
Yeah, and no one's stopping you from doing this. And if we make auto dereferencing, then it'll be very easy, where you just do like some vec2.
Function pointers automatically decay to or convert to functions, so you don't.
We don't even need that. Yeah.
What you call it? That's already a thing.
So then you could do this, and it's going to work the same if you really want to do that.
What you can actually do is you can, because of the way that variable declarations are passed. Actually, no, that used to be the case, but we changed it to what we now don't call. We don't call pass parameter anymore, because otherwise it would automatically convert a function type to a function pointer type here. But yeah, you have to do it manually, basically, just like in C, if you want.
You could do this if you really care about member functions. I don't, though. I'd rather have my funcporter var, like, even if it needs to change, it can be my funcporter var at the top level. You know what? I don't understand why the function needs to be within the struct, unless you're trying to save and restore it, which is just bananas.
Yeah, it's some weird stuff. Like the thing about with C++ is it's not just function pointers inside the struct. It's if it's like a v, if you have a v table, then the table is stored somewhere else, and the structures are pointed to the v table, and it's all horrible. And you need to, it's inefficient because you need to dereference two pointers to call a function and so on. So there's all this stuff going on in the background if you have virtual functions. It's fairly complicated.
Yeah. It sounds horrible. Calls or blocks? So a block would be kind of confusing. Do we want to allow that?
I don't think it makes sense for a block right now. And
it seems kind of crazy.
What I'm saying right now is because all of this is going to get a lot worse once we add references, because a reference is an L value. So then everything that has a value can be an L value.
Yes.
But let's not worry about that now. So
but that's going to be like a specific reference handle.
The reference is going to be a type, actually. It's a property of a type, because like a function can return a reference. And then suddenly calls can be L values. So references are like, it's as soon as you like, references are like this entire thing in the type system where they're
a bit
more complicated than pointers, I'd say. In that, because
which is ironic.
You don't dereference them explicitly and all of that. So
by making pointers non-null, they become more complicated.
It's less about non-null, but about the fact that you don't have to dereference them. Like that does a lot, because pointers, a dereference, all pointers are memory addresses that point somewhere, but in order to turn it into an L value, you have to dereference it. And that's like a very specific syntax you can easily check for. But but as soon as it just changes to as soon as this thing is used anywhere, like that's harder to check for, and you can't really check for that. For binary expressions, that is there a binary expression that's an L value?
Don't we have to figure out which one it is?
Yeah, but is there any binary expression that is an L value?
Subscript.
Subscript is a binary expression, that is true. But no, subscript returns a pointer. It's not an L value. You have to dereference it. Subscript in C that's the thing you mentioned earlier. Subscript in C is an L value, but not in this language, because it's just point arithmetic.
You are correct. I stand corrected. I always forget about that. I was thinking we would have had to handle that, which is funny, because I mentioned that we wouldn't.
Yeah. So I think for now, because we don't have references, we can just delete block call and cast to.
Is that cool?
Mm-hmm.
Okay. Horrible indenting, I'm sorry.
As well as function reference, because you can't assign to functions.
Okay, that's what I was thinking.
But I think all of these, and if, let's just, yeah, if is a to-do, we'll come back
Yes.
to that later if we want to.
Then declarations, unaries, variable reference, which is like the A case.
Yeah, variable X references is the easiest because variable reference just cogens the declaration and it's the same L value. That's the easiest one. Anyway, we were doing unary, I think. If we want to start with that one. So the only thing we care about is at, I think. So this could also just be an if, technically.
That's true.
It's always brilliant if you start writing a switch and then you realize I actually only care about one case. That's could have been an if instead. Yeah.
I can probably salvage this. Beautiful stuff.
Nice.
Hopefully this is a thing.
Token type 2, I think it's token type 2 str. But I'm not sure.
Okay.
Okay, let me see. Well, you can check
It's not in there.
word. Token type 2. Oh, I'm in the wrong compiler, my bad.
Yeah, it looks like that's a token type. And it gives a string back.
This is the right compiler.
Percentage S though.
Really? Does it return a const char pointer?
Yep.
Interesting. Oh, I suppose that makes sense. It is token type to string. Perhaps because it's not including, you need to include parser.h. It's probably not including that because parser.
A B C D E F G H I J K L M N O P. Element OP. There we go.
There we go. Oh god, I just saw the macros, like when you zoom in this much, the macros are horribly formatted.
Yes, line
wrapping.
That's why truncation is normally the better way to go.
Yeah, I typically never use line wrapping because it just looks horrible in my experience.
I don't, okay, truncate lines. There it is. Now it should work. That is much better.
That's much better.
I should set that in the in my Emacs files. I'm not going to do it now. L value. Okay, where are we? I'm trying to be mindful of the chat blocking things today. I think we're good at this the zoom level.
It's also only in the lower right corner now.
That's true. So if I keep things near the top, I should be good to use all of it. If I do that.
Oh,
that's better. Okay.
So
if it's an at, what do we actually need to code gen?
Well, in that case, nothing for the address. The address is just the pointer then. Because we already have the pointer.
Yeah.
Well, we have to code gen the operand. So this is the weird thing. Cogen expression calls cogen L value, but here cogen L value has to call cogen expression.
Mutual recursion. No.
And you might have to forward declare it for that.
Oh no. You're right, we do. Dr. Jekyll 2780 and secondary Gruel. Thank you so much for the follows. Do I need static in the forward declaration?
Yes.
Don't be mad. Too few. Okay, now it's just telling me this is the use. Context. And then this is going to be a unary Excuse me?
Operand, I think it's called.
Oh no. Okay.
Company mode isn't really doing too well, I think.
Toggle truncate lines is needed
God.
for company mode.
Jesus Christ.
When you're zoomed
Why,
in.
Emacs? Op, I think, is the operator. Oh yeah, that is the operator. I think apparently it's value. Value.
Naturally.
And technically it's only if the at is a prefix operator, but we don't have postfix at the moment, so I don't think we need to check for that. But if we ever add postfix at, then
Not postfix, right?
yeah, this is such a pointless check. Postfix.
Postfix at.
Postfix at, because unary operators can be postfix.
That's gonna be
Oh,
like
God.
concatenation. Like you can do
Oh god, oh no.
a at comma or something.
Oh no.
It'll be like hash or stringization.
Oh no, please don't. Jeez.
Yeah, I hope we never have to do anything like that. We should just have an actual macro
Especially
system that works.
because we don't have expression separators, so that would just be end up. So every time you dereference a variable at the beginning of an expression, it would just end up concatenating whatever is before it with it.
I did have a funny idea for expression separators.
Jesus Christ, what even is that?
We take a
this
look.
again.
Oh, if we take a look,
The bell? What?
it's the bell.
The bell.
The literal, like, ding character in a terminal.
Oh god.
So if you print this in a terminal, it would ding every time there's an expression separator.
I wouldn't recommend control characters for expressions, just say. For anything really, actually.
Well, we'd never use it because they're not really used in the language.
Yeah,
that's the whole point.
Like, if you're not using Emacs, then inputting this is a bit of a challenge.
Just Control Q, Control G, my guy.
Yeah, Control Q, Control G. Exactly.
The best part is that copy and pasting, you'd get this.
Yeah, and the problem is, like, if you like posting code online, like, do people now have to play the code, like backplay it to listen to the audio to figure out when expression ends? Oh. Yeah.
Max says, I don't have this on my keyboard.
Just use a teletype. Actually, no, even that doesn't help because a teletype only, it has a bell, but it doesn't have a way of inputting a bell, I think, or does it?
I don't have any way to put in a bell in new shell. What was that? That's what I said.
Oh.
Yeah, I can't even copy and paste the bell. No bells in new shells.
I was saying, I think there is a bell key on old teletypes, but I'm not sure.
I see. So on some old keyboards or machines.
Yeah, but I don't think that sends the bell character. It literally plays the bell. So
it's, hey, I can do that. Easy. Nobody probably heard that because of the compressor.
Funny. The address of this thing is the IR of whatever that is. So the address of this is the IR of the, well, code and expression doesn't return anything. It just sets it. You have to do yeah, the usual thing. Yeah.
Naturally.
Oh no. That's an interesting comment in chat.
If the compiler compile any file, make it say compile finish. It does. You just have to pass in -v for verbose, and it'll tell you that it generates code.
It generated code, that is true.
Currently, what you're mentioning is that...
Currently, you'll get a few warnings.
Oh yeah,
Nice.
that's right. That's not going to work yet. The test int. Hopefully and/or still works. And/or works, but there's no way to see that it worked. I mean, you could look at code.s and figure out if it compiles, but it's easier to just pass it
and/or
to pass in -v, and it'll tell you generated coded output file path code.s.
Which, like in the GNU style, if it doesn't print output, it succeeded. Typically.
Yes.
So that's why by default it doesn't print anything.
And that also is kind of important for like tests to make sure standard out doesn't get cluttered with a bunch of stuff. Not our specific test implementation, but
Oh, and apparently they meant say a bit more literally.
oh, what?
You look in chat.
I don't have if the compiler next gen compiler, no like voice AI voice.
Have the compiler say, I'm done compiling order.
Ah, thank you for translating. That makes a lot of sense. That would be amazing. It just like Kip.
Like what?
The car from what is that movie? HAL 9000. I don't know. A better reference, 2001: A Space Odyssey.
Oh, that I
Like
don't. I think I've seen that. Like I don't know when. I don't remember.
That's fair. But it's just like the ship talks to you and it's like,
file
compiled. Honestly, that's doable.
It was a pretty good robot voice, by the way.
Thank you. I've practiced.
I see. Okay. So that's unary expression is done. Why is it still complete token type 2 string?
I don't know. It's undeclared.
How to undeclare? What do you mean? It is in parser.h.
Yeah.
It's right there. Token type 2 string. I mean, then again, if you look at line 7, 8, 9, it's also highlighting all of that in red. So maybe just your LSP is a bit broken or whatever it is they're using.
So it says utils.h has red.
It's probably all of the files that...
It says not found.
It's not finding them because of the angle. So it's not... The include path isn't set properly for ClangD or whatever.
Oh, I know how to fix that. Hold on. That makes sense, though. Because everything's name changed.
Oh, I see. That makes sense.
Hey!
Yeah, there we go. That's better. I just like remember because whenever includes are underlined red, that's very sus to me because I've had that happen to me too many times.
See, LenserOS just does that. It's done that since it was born. So
yeah, you have to like, in order to get everything to work properly for LenserOS, I have to set some CMake variables in the environment and then reload the... I have to always switch between the CMake lists. Like if I'm working on the kernel, I need to load the kernel CMake. If I'm working on the on libc, I need to load the libc CMake.
And then switching between them is wonderful.
Yeah.
So node variable reference, we really don't need to do anything.
Yes, so for this, because a variable reference can only really occur after a declaration, so...
This is a symbol.
Yeah, it is a symbol, and the symbol contains the declaration. So we can just use...
This decal?
Yes, that should be an...
CodeGen this?
Yeah, actually, that should be it. But address, not IR.
Okay. And then...
This I don't think we even need to do this.
We don't need to do this.
Because the node that a variable references is the declaration. And if we get to a variable reference before emitting the declaration, then something went wrong somewhere. Right?
That's a very good point. So if we have... So if we have a is equal to 42 and then a integer, then we would need to CodeGen a integer first. But that doesn't make any sense. That's not well-formed code. So we don't have to handle that case. We could explicitly disallow it, in fact. Yeah. But I don't think we could because if this is null, we have big problems, right?
Yeah. That's what assert is for. You can just assert it.
Yeah. I was just testing you.
I see. I sometimes also forget that assert exists if I haven't used it in a while. I'm like,
It would really be nice if there was a function for if this is not true, then it's a fatal error. Just terminate the program. Oh wait.
And this will say
I don't know,
must.
can't reference variable before it's emitted or whatever.
Very beautiful. Cannot reference variable that has not yet been emitted.
That's nice.
Okay. I think this can help with a new line.
Mm-hmm.
Okay.
All right. Those were the easy ones.
Yeah, I've been kind of avoiding the hammers.
That's going to be the annoying one. So, for declaration, fun fact, what we need to do for declaration is we just go to what cogent expression is and copy all the code to here. Sorry, to where
Declaration.
Declarations in here.
Yeah.
So just grab Jesus Christ. Not okay. Hold on. Actually, yes. We need to emit the initializer even if we're only cogenning the L value. I remember having that problem in source in my language. So we always need to emit the. We still need to. Yeah, we need to load the value now. So we can just do a load from the address here. So this is literally just from the IR address.
This?
Yes. And I think you need to pass in the context or something at the beginning.
Yeah.
There we go.
Those are mostly unused.
Yeah, I know.
We just they've been around for so long. We're like, let's just keep it. It's consistent. Because I think one or two need it.
Everything else almost it goes into whatever you were in cogent L value. Except that if we're loading the value anywhere, we aren't loading the value, so the declaration doesn't load the value, it just allocates it. That's nice.
So
this looks about right, I think. Mm-hmm. Yeah, good. Oh yeah, it's LVAL now. Jeez. Oh no. Yeah, this is the problem I always have if I replace things that way. Because I have a function too in C line where I can select occurrences of the same substring or whatever in the buffer. But then I end up replacing parts of function names.
Oh no.
It's really like you just did with cogent expression to cogent LVAL. It's really annoying whenever that happens.
I think in Emacs, once tree sitter is a little more mature, it's going to be really powerful. Like search everything that isn't a function name. Like search only variable names or identifiers.
Well, there's rename variable is like the classic thing that you can do in IDEs. Also, that should probably be an ICE.
Unhandled literal type for static. Yeah, definitely a nice.
Mm-hmm.
That's a declaration.
Good. That's already done, basically. Except that we need to one thing, the very first thing. Every use of LVAL IR inside of the declaration case needs to be changed to LVAL address.
Even here?
In this case, yeah.
So what you're telling me is I should use query replace.
Yeah.
And I should do LVAL IR with LVAL address. So this should be replaced, and replaced. And then that should be it.
Should be it. Nice.
Beautiful.
See, query replace is nice.
It's very nice. I'm glad that you told me about it. I didn't know it existed. I mean, I knew it existed.
One command I use all the time in Emacs. Like half the time, I don't know what you're doing in Emacs, but query replace is the one thing I know.
The best part about Emacs is that you can write your own navigation functions.
Yeah, true. I have my own. Like most of my Emacs functions are just stuff for like generating LaTeX tables and stuff. I have a function that takes where I can copy something out from like LibreOffice Calc or from Google Sheets and paste it into Emacs as a LaTeX table, as a tabular environment.
That's so pog. That's amazingly cool.
Because I've just had to do that so many times that I just got sick of doing them manually. Anyway, that's fine.
Do we really not need this IR store? Do we just discard this?
Careful. We are storing the initializer in the address. That we have to admit that always, even if we just need the address. That's a problem that I ran into in Source as well, where I had bugs because I wasn't emitting the initializer. You always need to emit the initializer if there is one.
That's a good point. Okay, so yeah, that's good. That makes sense because it's the initializer of a yeah. I'm getting it now. So
Good.
now, before we do, okay, let's do it. Why not?
Okay, sure. I mean, if we want to do something else first, but we can do member access now.
Yeah, we'll do it.
So this shouldn't be too hard. Basically, you just need to get the L value for the left-hand side and then just offset it.
Okay.
So in order to emit, I need to get the address
Vector
of some
find
vector and add to it. So we're just going to call ourselves recursively here.
So we need this address because this must be an L value. Okay. So we basically, a member access, if I remember correctly, we will have a member access. Beautiful stuff.
Yep.
And then this has an address.
We need to emit it first, but yes. Code an L value because we just want the address.
Naturally.
This is confusing, isn't it?
Yeah. So now with this address, we need to use this in an IR load, question mark?
No.
IR add because we need the offset.
Yes.
And
the
then
offset is what?
It's the member access member byte offset.
Byte offset. And that entire thing is what?
That is the L value address for the member access.
Yeah.
Right?
There we go. Nice. What's it complaining about? I think you might have to load it into an II immediate because we don't have.
Oh, yes.
Yeah, create an II immediate for that. I think you can just do that in line too, but yeah, sure.
That's sensible. We need to set the type.
Oh, we need to set that. Does II? Oh, yeah, we need to pass in the type, and that's going to be just an. I would just make it an integer because that's fine. Because once we have if we ever add unsigned integers, if you're planning on doing that, then it's going to be a size T, so U64 probably then.
I definitely plan on that. There's a plan for there's a plan for U8, U16, U32, U64. Right. And the I corresponding signed versions as well.
And does integers remain integer or?
Yeah, they're all going to coexist.
Interesting.
Because like when you're just writing code, I think if you just want a number that's kind of big enough to do everything, a 64-bit number is that, a 64-bit signed number. Because if you're counting, go ahead.
What I'd maybe do is define the bit width of integer, because otherwise we run into the same problem that we have with ints and C.
Oh, yeah.
Where they're 16-bit on some platforms and 64 on other platforms.
Yeah, that's not allowed. It'll always be an 8-byte integer.
That's good.
That's the plan. Even on systems that don't have 8-byte integers.
Just do what
twice.
Do what we need to do with 128-bit integers. Just use the carry flag or something.
Exactly.
So for if, this is kind of a complicated one. is there any situation where this works well? Because I'm not. I ran into the same problem when I was writing the source compiler, and I'm not sure if there's a good way of solving this. Well, actually, then again, it has. So this only works if the thing it contains is an L value, right? So we need to check if the then and the else are L values. So I suppose what you can do in this case is you can just call cogen L value on the then and on the L.
Okay, so
because the thing is, what we need to remember is we're in cogen, not in semma. We assume that it's well formed. So if somehow an if that isn't an L value slipped by semma, then that's not something we're equipped to dealing with here.
So what you're
if we
saying
get
is
here, then we assume that the then and else branch both evaluate to L values because we're trying to use it as an L value. And it's on semma to determine whether it makes sense to assign to any specific if.
So if we could, I know this isn't a thing, but if we could, we would put an assert here that like then and else are both an L value.
Conceptually is but we implicitly sort of assert that by calling cogen L value on it, and if that fails, then that will fire the assert in the default branch.
Which means that all we need to do is call cogen L value on the then and the else, you said?
Yeah.
So if it's a block expression,
we could just do the same thing. That is true. And even for calls or whatever, like.
I mean that, yeah, I think we're going to have to, because if an if-then is a block expression.
Yeah, if it's a block, we just pass it through again, same thing. Yeah.
So this is going to be then. Is this not?
It is that, but it needs to be the context, I think.
Beautiful. Okay.
Which I don't think we're even using in here, other than just pass it to. I think we're passing it back to cogen expression, which does use it at some point. So we actually need to like kind of hang on to it, unfortunately, and just pass it along everywhere.
Is this a phi moment?
Context parameter. It just has to go everywhere. It's annoying.
It is.
No. Oh, actually, it is a phi, is it not? It is a thing. Oh god, oh no, it is a phi.
Because the address is going to be different.
Yeah, that is a problem. Oh god, how are we doing that? In that case, we need to do that in... Oh yeah. Okay, that is a problem.
To do,
yeah.
If as an L value is not yet supported, but it's in the plans, BB.
We'll see if that really makes sense at some point, because I think in C++, ternaries are L values, but then again, C++ has this entire statements versus expressions thing, so I think it's easier to determine whether this is actually an L value or not in C++. So
very true.
Because I don't think you can really end up, unless you're using statement expressions, at which point, yeah, that's a compiled extension. But I don't think you can really end up with like more than one basic block when you're cogenning a ternary. So that makes it easier.
Do we ever need? Well, when do we call cogen L value now?
When do we call cogen? We call cogen L value, for instance, in. So we need to go to cogen expression, and
that's where we're in.
Actually, the only thing that produces L values is a declaration, right? Everything, other things can be L values. Yeah, and a dereference. That is, so in the handling of unaries, essentially all of this can go now. And yeah, this is the thing that I mentioned. So no, this is install. This is store. So instead of all of this, we just call cogen L value on the left-hand side inside of this if. No, that can stay. We still need to emit the store and the cogen expression, but you can delete everything after cogen expression context right hand side.
Gotcha. This.
All of this just yeet.
And then
be
return.
gone.
No, we do need to emit the store, you know? We're cogenning a store here.
So we need to do this stuff.
All of that can go. You can delete that, but we need to do something else before we return.
When you said cogen the store, this is what that means to me. I keep seeing this cogen of a store, and you're saying we need to keep it, and then you keep telling me to delete it.
Right. What I'm saying is this code deals with the different L values and emits a store to different types of L values. We don't need to do that anymore. Instead of all of this nonsense, you can just call cogen L value on the left-hand side and then store to the address of the left-hand side. And the store doesn't return anything, I'd hope. So, because the store... Okay, actually, does it return an instruction? It does, I think, but... Yeah, I suppose you can set it. It doesn't really matter for a store, because I hope nothing tries to use a store. So yeah, this is basically the whole point of having cogen L value, that you can just call it like this. There we go.
And then now it makes sense that we can get rid of all this.
That's what I meant. Yeah.
Okay.
And the ice can also go, I think, because that's now handled in cogen L value. There we go. And for left bracket, that's different because that computes an address. So actually, no, this can stay here. That's thing. All of this can stay here because that has nothing to do with L values. That's just address computations. Because the thing is about pointers are addresses, but they're not L values. So this is just generating the value. This generates values, not L values. This sets the, yeah, you know what I mean, I think.
Yep. So we returned before. Do we still need to return here? I think we've handled everything because we cogen right-hand side. Whereas down here, when we cogen the right-hand side, that's for the left bracket. Okay.
Well, everything else, yeah. Oh, that's for subscript. That is true, yeah.
And then we have, yeah, more subscript stuff. And then all the other ones have both just emitted regularly.
Yeah.
Okay. So, okay, now unary.
So now in unary,
we need unary
here,
at.
that's interesting. We can just I think here we can just straight up always call cogen expression.
I think
we can just call cogen expression on the value. Because let's see, hold on. How is this organized? Can you scroll up? Oh, before that, I think it's just address.
You cut off there. What was that?
Okay, can you scroll up a bit again?
Yeah.
What are we doing here? They can also just go to look at it locally.
We're at the unary expression.
Yeah. So we can
Here's address of.
So what are we doing here? That's for address of. I think this needs special handling and it needs to be here because this also does not generate an L value, it generates a regular value.
Right.
So I think this is actually no. What we do need to change is, for instance, in the case for no declaration, expa is expa unary value address because now it's not stored in the value. Yeah, and the same thing in here. And actually, no. See, this is the thing.
It's the IR,
unary,
right?
we can just in here. What we can just call in this if here. I think we can just delete the, except for maybe, no, for string literals, that's going to be special handling. That's not even supported yet either, so we can just ignore that. But I think what we might be able to do here is just cogen L value, the operand, and just take the address. Because that's basically what we're doing here.
So you're saying cogen expression?
No,
cogen L value. So cogen L value on the unary value.
Mm-hmm. And then just the address of the value of the unary value becomes the value of this expression. Because that's what address of is, isn't it?
So we are converting
this
value address
is the address of its operand.
Yes.
See, this makes sense.
It does make sense. It's just it's hard to wrap my brain around all this being replaced by that.
Yeah, the entire switch is replaced by that. It just
yes.
Okay, yeah, sure. String literals. Who cares about those at the moment? We can probably also handle string literals as well. String literals aren't L values, so that's Do we want to take the address of string literals? Because those are, what even are they? Arrays,
It's
right?
a static reference. It's an array, yeah.
Yeah. We'll come back to string literals. We'll maybe leave it like
Exactly.
this. And we, for so he would just need to load, I think. So there's a check in there for function pointers, but I think that's nonsense.
Yeah,
You can just delete it. Why are you dereferencing a function pointer? Like, why? Don't do that.
which we could disallow in Sema.
Yeah, I hope we are.
We probably aren't.
If not, then it will crash horribly at some point. It will notice. So this is for at.
I'm just searching code gen.
Here we go.
We can only dereference.
Okay, yeah, maybe change it to type is pointer and the pointee is not. And the canonical type, oh god, this is again horrible. The canonical type, we need to get the canonical type.
So it might be null.
Yes, can be null. That is, and the thing is, the pointee type is we can only even that if it's a pointer. We can't do that outside of the. We have to do that after the if, because then we know that it's a pointer.
Hey, that means we don't need the thing then.
We do need the thing, but yeah. No, not in the if. After the
so
if.
we do need the thing.
We do need the thing in the case after the entire statement. We do that because we can't attempt to get the canonical type of the pointee if this type isn't a pointer to begin with.
I now see what you're saying. This is the pointee type, right? Or the pointee?
We need to get the pointee, yeah. That's that's this entire nonsense. And we need to type canonical, and we need to check that this is either null or not a function. Actually, if it's null, then that's also an error because you're dereferencing an incomplete type.
Yeah.
So actually, if it is null or a function, it's an error. That's a good one.
So if pointee
Maybe
type...
Maybe you want separate error messages for those, though. Yeah. Here you can... Yeah, okay, the source location, we do need that. Typically in like C, the error you'll get is cannot dereference incomplete pointer type or something. Yeah.
And this is going to be pointee type. No, that's null.
That is null here, so we
it's
have
gonna be this
to do...
thing?
Yeah, sure.
In case it is something.
Maybe technically that's the pointer type. So actually, yeah, that works, sure. And again, typically cannot is one word.
Thank you. I always write it as two, to be honest.
Yeah, cannot separately means something else. Like, what's a good example of that?
If pointee type...
I cannot help you is a good example. If you write it as one word, that means I can't help you. But if you write I cannot help you separate, then what you're saying is it's possible for me not to help.
I see what you're saying.
So the not, if it's separate, the not negates the help, not the can. Yeah. So just in case someone tries to dereference function pointers for whatever reason.
Cool. It's probably the least broken code I wrote today. Now let's...
Pretty good too, though. So this is a lot simpler now. Brilliant.
So this is address, right?
Yeah, this is this an address? Okay, hold on. No, it's not address, it's value, because we're loading a pointer. And this is the complicated thing. Yeah, a pointer is an expression whose value is an address, but it's not. It doesn't. It's not the address of the pointer we're loading. It's the value of the pointer that we're loading.
Okay.
Yeah. So
I'm just. Okay.
I don't know what that said. L value.
It's okay.
Is this it? Are we done?
I don't know. That's... I gotta... Can you give me a... It's not giving me the normal autocomplete. that it does.
Oh dear.
There we go. There it is. I just didn't want to type all that again. Hey.
Hey.
Well, that's really surprising.
In fact, you can do Control R like in Emacs and then search back through your command history, basically.
I can do that here as well.
Go.
I don't know what I would search for.
Like
all that.
Some command, like bytes array or something, and then it would pop up. Should pop up.
Nice.
There you go. And then you can and grab the thing. Yeah.
Wow. Okay.
In less fancier shells, that's how you search through your command history. Other than just straight up running the god. What I sometimes do is just grep history, like history pipe grep.
Yeah, I have new shell, so Control X brings up the history. I should have remembered that.
Nice.
Up to 10,000.
Mm-hmm.
And it's full.
Bash shells are just a history command that prints it.
Nice. Ooh, okay. So I could have just done, yeah. Very cool. Okay, anyway, getting distracted.
Wait, seems to be working? This seems too easy. Did we miss something?
I know, I'm forgetting something, right? We didn't get it right the first try.
Third time that I'm maybe not implementing them myself in this case, but looking at or thinking about L values in the past like 2 weeks, so maybe it's still so like present that it's not that hard anymore right now, but still.
I think we broke optimizations pretty hard.
We broke something, it seems.
But a lot, like constant folding.
We broke optimizations, I think, because the optimizer still thinks that addresses are stored in. It doesn't know about the address field. It still thinks it's stored in IR.
Am I on the wrong code base?
No, I think you're right in the right one.
Okay, I'm in the right one, yeah.
It's called intercept now, yeah.
That's the same numbers.
Yeah.
We just coded for an hour straight and we didn't get anything wrong. I don't think I've ever had this happen.
Interesting.
Have you?
I think so sometimes, but
you were
depends
smart.
on what I'm implementing, I suppose. I mean, what I usually have is if I write a new compiler, is I write the Lexa, and that usually works first try because I've written so many Lexas before, and I always write the same Lexa. But in the parser, whenever I write the parser, I typically forget to discard a token in at least one place, like the typical error that I made.
That is true.
That usually more or less works, but I always forget token. About a token. There we go.
So I can.
So wasn't there something that wasn't working before because of how we were handling things? Like,
I don't remember, to be honest.
What you can do is, do you have a member access test?
Not yet. That's a good idea, though.
Also, what you can do by the fact, I'm not sure if you've used this feature, but if you go to, for instance, just check out any of the overload tests.
Okay.
I think any of the overload tests. If you go into any of those, I suppose you could invoke it manually. That also works. Yeah.
Ref and call?
I was actually I meant look at the source.
Oh, okay. Thank you. I'm slow.
All you can do is yeah, but see where it says labels, you can add a label to a test. And then if you're using the script, you can just run all tests with a specific label. So if you do currently the script doesn't support command line arguments, so I think you have to do labels equals. You have to set environment variable. I don't know how to do that in neutral for one command, but in bash you'd do labels equals that, and then in the same line run the command.
Yeah, I'd have to do let env.
All the overloading tests with that, for instance. So if you only want, but you're invoking the compiler manually right now, it also work. But I was saying if you wanted to write a series of tests, like member access only, and you wanted to test all of those and only those, then you could do it this way with this label.
I guess we just have to do it. So this is member access, I guess. Mm-hmm. So we're going to do vec2.x is equal to 42 vec2.x.
Sure.
Let's do. How about we do vec2.y so that it has to actually calculate an offset.
Yeah.
Or we can also just do vec2.x is 20, vec2.y is 22, and just add them together.
Yes.
You return. Or 69 also works, yes. I've seen too many sorting streams to not know that 32 plus 35 is 69 without even having to calculate that.
It's memorized. It's ingrained at this point.
Mm-hmm.
Okay, so that's member access in examples.
Oh, it's in examples now. I suppose that also works.
Okay.
I think we haven't implemented that syntax yet. That needs to be a token.
Have we not?
I don't think we did. I don't think we did. I think we ended up talking about Arabic instead.
You're probably right.
So we need to add a token. So this is
it's quite easy.
The tokens are in ast.h again. So now we get to name the token, but I suppose we're just going to call it :@. Wait, didn't we? Colon greater than is already a token.
Yeah, I was like, I feel like we did this.
Did we not? We did. Okay. I feel like we're not passing it then. Go to identifier. We are calling next char, so that's right. So to pass identifier isn't expressing it. Whatever pass function passes expressions with here. Do we not have? Yeah, we have an else if tk : greater than. We pass the it's the if below that, but yeah. So this looks right. Why is it complain? Did we discard it? Would do. Okay. What's it complaining about?
Saying it's expecting a base type, but it got 37. So parse type is incorrect.
We are Oh, hold on. Scroll up a bit. Are we discarding the identifier?
We went somewhere else. Hold on. I was like, that went to the wrong spot.
We are discarding the identifier because that's the identifier. After that, we have the : greater than, which we are discarding as well. So we should be on the type.
Yeah.
In pass. Oh, pass type. Does pass type know how to deal with the type keyword?
It probably does not. I don't remember writing that.
Does it? If no,
that's a symbol type. Token
that's
type.
A symbol type. Token type here. So it does know how to deal with that. Interesting. Invalid base type.
Good thing your lectures always work first try.
So what is token type? It says expected base type got what? What did it get? Like in the error message in. What is 37? Can you go to the tokens and see what's 37?
Less than. Did I type it wrong?
Than? That is a greater than.
Okay, what have you done? This is a copy and paste error.
Can you go to... No, that's not it.
I'm just checking that these are right. Okay, so greater than.
Yeah, those are right. But wherever the colon is left, we did something wrong. Wherever the colon is left. Hold on, let me look at that. Next child that discards the colon. If it's a greater than, we set it to : greater than, and we discard the greater than. So this is right. Interesting. It's definitely the... How are we getting here? Why is there a greater than sign?
Type does not equal token type. So token type could be messed up.
Token type could be messed up? Why would it...
I don't know how that works.
Since we have implemented LVALUES, can you push what you have and I can step through it in Studio, or I can step through it in C-Line?
Yeah, your mic seems to be cutting out more than usual.
Oh, I can turn up my volume if that helps. That's Discord.
Yeah, that'll be great.
Okay, I've turned up my volume a bit. Is this better?
That's much better, yes.
Yeah, because Discord does this annoying thing where if my volume is too low, it just mutes it. Don't do that then.
like you just get background noise, I think. But I suppose I
Yeah.
can. That's usually annoying if I'm in a call with multiple people. But I suppose I can turn it off now because that's so. If I just hold
Max
on,
says turn it off. The chat
there we go. Is this
is
better?
behind you.
This
Oh
should
my
be
god, that's
better.
so much better.
Okay,
Should I do the
so
same thing to you? Do you care?
in inputs and that's in on under voice and video, you can disable input sensitivity and just turn it all the way down. I think this is better apparently.
Okay, not input
So
volume. That might break things.
input sensitivity is all the way at the bottom. If you go to voice and video in Discord, is what I meant. Not all the way at the bottom, actually. Nowhere near all the way at the bottom. But if you just
OBS
scroll down,
virtual camera? Oh my god.
there is input sensitivity, and you can
Oh my
disable
god.
that. And apparently that helps. So good. Jesus Christ, Discord.
Advanced
Why?
voice activity? Okay, I'm getting too deep into this. I put the thing all the way to the bottom. Hopefully I sound better for
Good.
you.
Yeah. You need to disable that. There's a button under input sensitivity, and then just slide the slider to the left.
Beautiful. Okay, you do sound a million times better. I'm glad you did
Oh my
that.
god. Then remind me. Okay, you have to. I'm gonna keep this disabled now. Good to know. Good to know. Good. So
Okay, I gotta name this thing. This is gonna be, what are we even doing? L values.
actually, I'll be back in a couple of minutes. Okay, that's all right.
That is all right.
Good.
Anytime. I will see you when you get back. Have fun. It's just us now, chat. The teacher's gone again. Grab the candy. Everybody grab the candy. Oh, they're not gonna know. They're not gonna know who it was. Nobody say anything. Nobody say anything. Okay, I'll give you each a piece if you don't say it's me. I'm a nerd. I don't think I can do this example. Max says it's you. No, no, don't say anything, chat. You're gonna ruin it for me. He won't trust me if he knows I took his candy. Sure. The beginning of the end. No. What should I call this? Probably begin. I'll do code gen. Begin separating L value logic. I can't believe what we wrote actually works mainly. I mean, it's not perfect, obviously, but okay. While I'm at it, I probably could take the time to properly make a PR already, I guess. That's not a problem. Let's call it cogen. Make L values reason about L values logically. That's not very good. What's a better one? I'm not good at titles or naming things. Basically, I should just say L values should L values. I'm just gonna call it cogen L values. You know, I don't think there's any rules. Beautiful. It's now a PR. It's on intercept. You can test this broken code yourself. So expected base type got 37. This is really confusing. So when we get to expected base type here, how does this happen? What is our actual... What do we have print? We have AST print node, scope tree. I don't think we have AST nodes in the Lexer, really. We have print token? We have token type to string, don't we? Why don't we use that? Huh. Excuse me? What just... Or is this a different error? It's only here. What is happening? Oh my god, chat. I'm running the wrong executable. That's why oh, that's why it works. Okay, hold on. Ah, it's still left over in there from the old name. Okay, this is much better. Because this actually is a real error, chat. This is something that I made a mistake in writing an example, and the compiler tells me there's an error. Turns out when you run the correct compiler, it actually helps you. Max says don't tell him. Nobody tell him. It's embarrassing. Okay. That's an interesting one. Huh. Cannot assign to non-L value type integer. So, and we're not even printing the IR. Can you give me the AST? No. Seriously? Okay, nope. This is before the AST can be printed. Okay. Give me the AST. Okay, before type checking. That looks wonderful. And then give me, what's the actual error we're getting? Okay, I'm starting to understand. So when we access vec2.x, that is an integer. And in CodeGen, it looks like we say you can't assign to an integer. So before, Max is wondering why is everything null. So in this AST, I passed, it's a bit up, but I passed -- syntax -only. And what that caused was before type checking or any type reasoning has been done by the compiler, it prints out the AST. So this is just what the parser spits out. It doesn't know the type of things. It just knows that there's a binary expression with plus, and there's a member access on one side and a member access on the other. Whereas these types aren't actually known. But I know that this program will end up, because the var myvec2 has been defined up here to have vec2, eventually we'll be able to fill out all these types and say myvec2, the variable reference to that actually is a vec2 as well. So then this is a vec2, and then the member access of a vec2.x can then be resolved to be an integer, and then this is an integer. But when that's an L value, it looks like we used to do some hacky thing in CodeGen to kind of disallow not something like 34 is equal to 92. Because if you have an integer type on the left-hand side of an assignment, it doesn't make much sense. But now it makes a little more sense. But really, that just means that in SEMA, we're not setting the type properly. So we need to check out where, when we set the type of an L value, it's going to be different than setting the type of a non-L value. So what did we just go through as an L value? We basically need a dereference. A dereference is an, hey, we even have a nice handy static helper is L value right now. Look at us. This is everything we just handled. And eventually we're going to need some more stuff in here. So fix me add if, fix me add member access. I think what would make more sense is add member access a.b. Okay. I don't, because they're not always L values, so this is, I don't even know if we use this, to be honest. We do. And apparently it passes currently somehow. And we get all the way to code gen. Cannot assign to non-L value type integer. So that's, we're getting here. The type checker is saying integer isn't a proper type. So left-hand side is a node. Oh God, no. Get rid of that right away. Jesus. Left-hand side is a node. And basically, we type check the left and the right-hand side. So when we type check the left-hand side of a binary expression, there's kind of a trick here, because when it's an L value, aka a lot, but not all the time, when it's an L value, the type is going to be a little different. Is it not? Because we're, for example, we're going to be accessing the address of things. So it's going to be a pointer level of indirection. So if the left-hand side is an L value and it's being used as one, right? So it's not currently an L value because it's an integer, but, oh man. So if the left-hand side node is an L value, what is actually being checked here? Is L value just switches on what kind it is? So I think we literally just need to add member access from the AST. That was it. And then we get a seg fault, folks. It's as easy as that. Why would that seg fault? Expression type equals left-hand side type. Interesting. I bet you the man in the chair will have a lot to say about this. So when it says cannot assign to non-L value type, what do we try? This is the complicated one. Yeah, you could say that. So we need to make sure the left-hand side is an L value. So anything that can be an L value should return true. So I think even if should return true. Because I don't think we want to do like complex type checking in here. So a member access when its parent is, yeah, I don't think that matters. I think we're good. We still have basically just a seg fault. And then some weird, what is this? What do we have happening? First time chat, dog weather, ouch. This is in C and I'm wondering if phantom types could help. I don't know what phantom types are, so I don't think that would help anything very much as far as the speed of development. It may help the quality, but it would take a long time and I don't know if that's worth it right now. What are phantom types? Segmentation fault. Where's L value called? I'm in the wrong spot. It's also called ampersand, which gets the address of an L value. We do want ampersand to be working on member accesses. Do we then assume that the value is of a certain type? We don't access anything its values. So where are we actually crashing would be a good question. Can we...
All right.
Yo.
So, where we're at?
It's crashing.
It's crashing. That's interesting.
But we
Did
can
you
print
find
the
the
AST.
problem?
Yeah.
What was it?
I don't remember. Don't look at chat. It's fine.
You can do a diff.
Everything's fine. It may... Don't worry about it. There's a new branch. There's a pull request. First time chat from Dr. Jekyll 2780. What did you say?
There's a pull request, you said. Interesting.
I've opened one with the current branch with the changes.
Oh, I see.
Yeah. I have changed some stuff, so I should update it.
Yeah. What was the problem? There was something wrong with Alexa or in the parser?
Yeah. It was me. Don't worry about it. Yes, the Lexer. Max, no. Chat doesn't want me to say it.
All right, what in the world is going on?
Nothing. I just it was something I did. And chat was like, "Don't tell him." It's fine. Dog Weather is wondering if phantom types could help. I don't know what those are. Oh, he has a big long thing now. It's a part of the parse don't validate philosophy. Phantom types are types that are erased at runtime, so have zero overhead. That's just how types work. I don't know what you're talking about. Okay.
Yeah, that's just how types work.
That's how static typing is. Max says, "My bad, I did it, sorry." Don't worry, Max. It was the fun along the journey that counted. I should commit these changes. What do I call this? Minor. Small hiccups. Sure. Okay. Most recent changes are up to date. And it's just seg faulting now. So that's wonderful. One thing I've done...
To recompile, was that it?
No. Guess what command I had saved in my history? Guess what executable it ran? The name of it.
Oh, I see. Interesting.
It was not this.
That would do it, I suppose, yeah.
I was calling funk, which still existed.
I deleted them. Have you deleted it already?
I did delete it as soon as I figured it out. Yes.
That's good. See, the command is so long I wasn't even looking at it.
That's why I didn't want to rewrite it. It's too long.
Yeah, but that explains why the token never got discarded, because the way I was looking at it, there was no way that wasn't right. So that was really strange.
Yeah, and then also I wrote like vec2.x was in the example.
.x.
So I had to make my vec2.
Oh yeah, that makes sense.
Yeah, I had the type using it as an instance.
Oh, I didn't even notice that, honestly.
Then in the type checker, we were running into this error where it says cannot assign to none.
Wrong, it seems. Yeah, LVALUE needs to be updated.
So I added member access.
That's good. That's good.
And now it crashes.
Now it crashes at 8. That's not right. That's not a valid pointer. Interesting.
Yeah, these aren't either.
Crashes? Oh, the compiler crashes. Okay.
Yeah, it's an ICE. I think it's a crash during an ICE.
That doesn't make sense.
Is it not? Does segfaults print this?
Hold on. Yeah, segfault prints that. Yeah.
Okay.
We are catching segfaults. If you go in, I think it's platform.c.
I see.
If you go in there, there's a segfault handler, or rather an unhandled exception handler, as it's called in Windows. On Windows, so we are handling segfaults to try and print a stack trace, which
it works on Linux.
Really working too well on Windows, it seems.
Oh, well,
also,
it works.
These warnings are super annoying.
It works in MSVC.
Hold on. Can you before we start missing any warnings that actually matter? What are all of these?
It's the stupid platform stuff. It's Win API.
Cast function type. Just disable that warning. No one cares about cast function type. If you're casting functions and you're doing something wrong, that's on you.
And then
Like,
there's a bunch of sign conversion ones.
Those we gotta check, but not in that file. But I think you
These.
can just.
But
okay.
It's fine.
Oh god, yeah, that is
It's
interesting.
stupid. We would have to cast this to an int64 and then make it negative, or make it negative and then cast the whole thing. It's just, it's
Or
C.
change the parameter type to int6040, yeah.
But it's already promoting this. And it's doing the calculations properly. Negative unsigned still sets the bits.
Yeah, that's true, but it's still interesting.
It's something that could be fixed, I guess. I'm not peeved about it. And this wasn't here before because
My
varargs.
only concern is that this might hide any warnings that actually matter, such as what we got last time, the like unsupported pointer cast or whatever, where we forgot to rename a type somewhere that was an actual error.
I'm all for getting rid of them. I just don't want to.
Yeah, it wouldn't take too long though.
I think we can just do W no cast function type. I'm fine with that.
That would be a start. Or we can just add a pragma, disable it locally or whatever. But I don't know to do it. I mean, I know to do it with GCC, so that would be an option.
Where are we? What are we doing?
Disable it just in that file with a pragma. That works.
W no cast function. We'll just get rid of it. I don't really think it's a big deal.
Yeah, probably not. If you're casting functions, then what the hell are you even doing?
Yeah, not in the compiler.
At that point, you have to know what you're doing.
There we go.
That one of any help there anyway. So,
and then we have force inline and D word.
D word. Things I can't check these too well on my system because, well,
I see. Unused but set because we haven't done casting.
Yeah,
Missing initializer for source location of parameter.
Yeah, source location.
Not handled in switch.
Not handled in switch. That one is a bit more of a concern. But it should be when it's not even it will crash in ASTC then probably in AST3 or whatever. But we're not even getting there, so
yeah.
We'll fix that whenever that comes up. Anyway, let's get back to what the hell is that?
Yeah, the warnings don't. We can get past type checking. Everything looks good.
This is probably, why this probably is. It's because I can probably even tell you where that is, and it's everywhere we are using like allockers, because formerly the value of an allocker, meaning the IR field, would hold the address, but now the address field holds the address. So the IR field is null everywhere.
And
and it's used in the register allocator and in the backend. So everywhere we're using -IR, or actually even in IR.c possibly when we're printing it. We should probably start with printing. Can you print the IR currently? Then we should start with intermediate representation.c.
It segfaults before we even get to printing.
Good. It probably segfaults while printing, because that accesses the same things as register allocation. So if we go, just go to, where would that be? In representation.c and just search for IR allocker.
What are you saying?
What I'm saying is, how
like the literal word. Are you saying locker? I'm sorry.
Alloc-A is how you say it. Alloca.
Alloca. Okay, that I say alloca is how. Yeah. Okay. That makes more sense. And then the R was from the British.
Yeah.
I know.
IR. So everywhere we're using an IR allocker and where we're accessing the IR type member of it. Oh, sorry, the IR member of it. We need to change it to address.
So
apparently not here.
Okay.
Apparently not binary instruction cases. What does that do?
I don't know. Where were we?
What does all binary?
It's just all the cases.
That's all for binary instructions. Never mind. That's fine. Yeah, that makes sense.
So
not here. That's in cogent.c. We were in intermediate representation.c.
Well, yeah, we searched them all. There's alloca. There's nothing.
There's nothing. Good. Then it's... Wait, what?
That's what I'm telling you. It doesn't make any sense. So that's why I'm thinking it's in code gen.
Yeah, so in that case, we just need to kind of figure out where the segfault happens.
It would be great if you could do that. All the changes are pushed. Yeah. ETs. Because we have two failures.
All the renames. I just pulled all the renames. Jesus Christ.
Oh, yeah.
Test. Oh, God. Okay. So what are we even compiling here? What are we testing? Member access, right?
Member access.int. It's a new example.
Okay, first I need to rebuild, preferably in debug mode.
Beep, 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 beep.
I need to delete my CMake cache, obviously.
Yep, pretty much everything.
Yeah, great. CD into here. Actually, just RMR builds.
So
it's not like there's anything in there that matters anyway. There we go. Oh God, I'm getting all the sign conversion warnings.
Beautiful.
Okay, let's see. We are building. Oh, it's no longer called func. It's now inc.
That's right.
It's now inc. Oh God, all the commands in my history are wrong now. And we are compiling. Sorry, what again? Examples.
Examples member access.int.
Member access. It's not here. You need to push that. You
member
have a
_access. Pretty sure I pushed it. I definitely pushed it. You didn't. You're on the main branch, bud.
Oh my God! Sure. What's the branch called?
LVALUES.
Values. Sure. Remember, here we go. I get expected expression got type if I try to compile that.
You got.
Did you really push the latest changes?
Yes.
Oh, print AST. Print AST. I don't even get to that. It crashes in Semma for me.
Cool. Where's it crash?
I'm getting an error. Expected expression got type. Oh, because you haven't committed. It still says vec2.x for me. You haven't committed that, or at least not pushed it. It still says vec2.x for me. In member access.int.
I don't think it's me.
Did you push your latest changes?
You can look at my screen right now if you want to know that.
I am.
Look, it says small fix-ups. We can look at the diff where it says myvec2.
Yeah, but the thing is, if I go to member access.int, it says vec2.x in the file.
Yeah, that's on you. Because on Git, this is the most recent commit where origin LVALUES, the remote, is up to date with.
Sure. If I check out a branch, it doesn't pull it, even though I've never checked it out before. Thanks for that, Git.
That's correct.
Oh, that makes sense. This is okay. Now I'm segfaulting too. That's nice.
Beautiful.
Good.
Where?
Now I can test it. Oh, it's trying to search for func, and that doesn't exist anymore. I've got to delete that thing now from here. So we are compiling. The working directory is
Max says, "Do the C line magic."
C line magic. I'm about to. Examples member access.int.
Isn't this what we're
sure? Where are we? Error running in C. Oh, it's not in that directory. Yeah, that makes sense.
Build in C.
Yeah, it's build in C. That's right. That's not what I'm trying to edit. I'm trying to edit this executable intercept build in C. This one. Good. And am I compiling with Clang, by the way? I hope I am. We'll see. Okay, let's see. Okay, we're raising an ice in main.
Beautiful. That's understandable.
Platform read file, apparently. What?
Are you sure?
I misspelled the path, didn't I? I misspelled the path, didn't I? Examples, member access dot. Oh yeah, because the working directory is wrong. That makes sense. I misspelled the path.
Rip.
Okay, so it's
address type is null. Interesting, because address is null in we're cogenning the root and we're cogenning a declaration. Yeah, we forgot to admit that makes sense. In cogen expression, we need to actually cogen the L value. So cogen L value. We forgot to do that here. That makes sense.
When?
In no declaration, we need to actually cogen the L value.
That's a good point.
Yeah,
Otherwise,
that makes
expression address will be nothing.
Yeah. Okay,
Sorry,
that
unimplemented.
still didn't do it, in which case I'm going to make that change here, and then we're going to run it again and see if what the problem is. Code.
I hit a sorry unimplemented.
Context, expert. Save, compile, blah, blah, blah. Okay, let's see. Where are we crashing now? Node member access to do implement. Wait. What? Where is that? In Cogen expression. Oh,
Yeah,
there's still no. Oh, well, yeah, that makes sense.
that's good. That's a good place to crash.
You know, it seems. Oh yeah, I am hitting that to do. Nice.
Build, disable, cast function type warning. Okay.
Yeah,
Latest changes should be pushed. And then now we're just really doing code gen, right? Of member access.
Yeah, now we need to do this. And this is very simple. We just cogen L value, the cogen L value this actually, this expression. No, we cogen L value this and then we load from the address. That's all we need to do.
This?
We need to do the same thing as that, basically, yeah.
That's
fascinating.
I know, I was like, wait.
That is interesting.
What about all this stuff?
Yeah, we did that in cogen L value. We just did that. That's cogen L value. Just
nice.
That. We did that. Just not here.
If this works, I'm
at 69. Oh, it works. Would you look at that? We have structs that are actually usable, and it's doing a Leah. Oh, okay, yeah, that's right. Leah move 34 is interesting. Oh, that moves it into that, yeah, because that's the address of the first member, and then with somewhere we need to add X. We're moving 8 into RDX further down, adding that to RAX, which holds the address. Yeah. Sure.
And then
that's
we
good.
dereference, we store RCX, which should have.
We're adding into oh yeah, the operands are the wrong way around. It's stored in RDX, so we're adding RAX. That's the offset into RDX. Good. Yeah, I think that looks about right.
Yeah.
Nice.
We're doing a lot of zero offsets and calculations.
Yeah, but that's like minor.
It's very minor. But once we fix, I wonder how broken is optimization now.
Oh yeah, good point. Let's try that.
Because it's gonna crash.
Probably broken.
Okay, no, it didn't crash.
It didn't crash.
It also didn't do anything.
It also didn't do anything. Yeah, because optimizing away structs is kind of that's a bit more complicated.
It is. Well, it worked.
It seems to have worked. Yeah. Nice.
Holy crap. This is like maybe the first time we went an entire stream writing code, and then it works.
And it only took us about 2 hours.
We're improving. You can argue we're improving.
We're improving.
So this is now a test. I just copied it.
This is a test. Nice. So I can reset my git reset hard head. There we go.
I may have made a mistake.
What did you do? Jesus Christ. Build func is not recognized. Oh, yeah, we need to change the test script. It's trying to run func.
I thought we looked at the test script and it didn't have un anywhere.
Let's see. No, un not, but func. Yeah. So here, that's one place. And then below that, that's another. And then somewhere else probably too. No,
that's
good.
It.
That's all of them. Yeah, I made it a variable.
Why is there an underscore?
Oh, because I'm stupid.
No, it's just habit. It's really weird to have that happen. So, fun compiler. Yep. Okay. Well, now that should do it.
Nice.
Oh, yeah, that looks about right.
That looks about right. And actually, what you can do is, because you're in a terminal, how do you set? You're using new shell, right?
Yeah.
How do you set an environment variable for one command in new shell?
I don't know.
Can you do just like foo equals bar and then run a command? Does that work? Like foo equals
That
bar
does
and run.
not work. I've tried that. New shell let env versus. What just happened? Let env. Okay. It won't be that hard. It's similar to the export function in
Yeah,
bash.
we don't want export, we want the normal.
Exactly.
With env apparently. So with env, there's that thing. So you can do
Maybe one shot environment.
apparently. So there's this. Hold on. I can copy a link for that here. There you go.
Oh, they do allow it now. Sweet.
Oh, you're on the same site as me. Yeah.
The new
No,
shell
that's in
book.
Bash. Oh, can you do that now?
I think, yeah, they say inspired by bash.
It
That's
does
new.
say $env.foo, so
Yeah.
yeah, you can try that now. So what you can do is you can do enable test colors in all caps and with underscores
Here?
and set that equal to 1. Equals 1, and then run the there you go.
Nice.
Now you have colors. That makes it easy to tell what's going on.
It's looking great. And then you were also saying labels. But we don't really have a bunch of labels right now.
We don't have labels, right? If you only want to run like optimizer, overloads, there were labels for that, but we haven't. Jesus Christ, what happened?
There's a few issues.
Okay, let's look through them. Let's like scroll up a bit and see.
We should pick one. Like, what's a problem that you want to look at?
If you scroll down, okay, hold on. Oh, the shadowing, that's interesting. What? That's not right.
Yeah, that's not an incomplete type. We got some bad things happening, clearly. This is the exit code for access denied of memory, so we're dereferencing a bad pointer.
It's segfaulting, I see.
Kinda, yeah. Dereference bad pointer is this.
Okay.
So byte is now an integer, now incomplete types.
Interesting.
You cannot dereference function pointer type.
Oh, I see. So we might have to allow dereferencing function pointers, even though that's because it's done implicitly. Because I think what Semma does, it literally just inserts a dereference expression. Well,
Exactly.
we do need to actually dereference the function pointer, but it's just done implicitly by inserting a dereference expression.
There's a lot of these.
Those are in the optimizer.
Yeah. Nested calls, negative numbers. How do we break negative numbers?
It's segfaulting. It's just segfaulting, apparently.
Yep, there you go. So what do you want to pick?
I don't know. Is that a simple one?
No. Everything's broken. It's not simple.
A test that's simple.
Negative numbers.
Cool. Let's pick negative numbers. What's negative numbers?
It doesn't matter. We can just do it ourselves.
Let's run that, yeah.
Went a little too far.
Okay. What are we looking at here? Declarations broken, perhaps? That might do it. When we emit the initializer of declarations, are we emitting it to the right thing? Hold on, let me take a look at this for a second. So we're declaring a... What's the code, actually, for this? I can just look at it here, actually. Where's test, negative numbers? What's the code? What's the code for that? It's literally just, it's an initializer. It's probably initializers that are broken. That could be it.
I don't think initializers are broken. It looks fine.
Yeah, let's take a look at this because the AST looks right. I not quite sure what's going on in the IR. That's not...
Doesn't make any sense.
Quite right, yeah.
So the declaration of A
Okay, it's not declared. Well, oh, it's always a static ref. That makes sense.
It's a static
Okay.
ref.
Sense. Never mind. Okay, that makes more sense.
But then
Oh,
we
in IR, I know what the problem is probably. Go to IR in the code. Go to IR static ref.
where? What does that mean?
Where? That's a good question. Actually, that's a good question. Where?
What are you talking
Let's
about?
try. Okay, where are we generating static variables? I think that's
Generating.
it's in Cogen LVALUE where we're creating them, right? But that I think is working just fine. That's this in here. We have IR create static, and we assign that to the address. And that looks about right. Yeah, good.
So we load the effective address of A into racks, and then we move A into racks. So now racks has -2. And
Reloading from -2.
and then we move 0 off of racks.
We're loading from the pointer -2 into racks.
Yeah, so
That's
that would be our issue.
Yeah, we're loading from. I see what we're doing. We are trying to move into or loading from the value of the variable instead of from the address. That's what we're doing. So somewhere where we oh, where do we code in the initial? Actually, let me take a look at the code for the initializer.
Right
The code
here.
for the initializer should be right? LVAL address.
Is it this thing?
Yeah, all of this. Hold on a sec. Init static literal. If it's static, that's that if. If it's a number, so if the initializer type is a number, then we create a literal integer. That's a thing now. Interesting. And we set yeah, that should be right. Otherwise, we store into declaration init. We store declaration is not into LVAL address. That I think is right. I know where probably. Can you go to the x86-64 backend and look at how store is implemented there and load?
It's a mess.
Just search for IR store and IR load.
Yeah.
Yeah.
I've done this a lot.
Indirect store. Yeah. Store. Okay, we are operating on registers here actually. Hold on.
So, and instructions. So the instruction we're passed is what? So when we emit instruction, right?
Here we go.
So block instructions.
Yeah.
So the address is never put into here would be my guess. But it is because we're calling the same IR things, that auto insert.
Yeah.
So why are we dereferencing -2?
Let me take a look at the code here. I can actually just test this myself too. Like what is it that we're testing about? Negative numbers.
So A plus 2 should be 0. The var A we need to load. So when we add 5, 6, that's load 4, do this, blah. So when we declare A, okay, hold on.
It's somewhere. This is a static variable, right? So if we just search for IR, is it in here maybe? Hold on.
So when we load 4, why would we load 4? We load expression address.
IR static variable. No, that seems fine. Static ref. That also seems fine. wait. Does the IR make sense? We're loading from
No.
3, we're loading from 3 again.
Look, yeah, this is the problem. This dereference. There's
Loading from
another
4.
load.
Ah, yes, this load isn't correct. What is this load?
I don't know.
This load is probably, is that the use of the variable? Hold on.
It's the add. It's IR add.
IR add, which is an add of a variable in the literal. So when we emit a node variable reference,
It's in here. This mess of a
Where do
thing
we-
that we subscripting. Probably not subscripting.
Why are we using subscripting here? That can't be it. We're not
No,
using
but
subscripting.
That's true. So we
Add adds left in a cogent expression, and that would call whatever the cogent is for variable reference, right? Okay, come on.
So a variable reference is just cogent regularly, right?
It should be. Let's see.
Yeah, it's just a load. So how would
Load of yeah, well, it needs to load the address, not the IR. It needs to load
Yeah.
yeah, that would be it.
I was like, a variable reference needs to load from an address. I was like, I had a golden moment.
That's too too fast. You went too fast there. You need to also cogent the L value first. So you need to call cogent L value on expression.
That's gonna get me forever. Oh, and context.
Need to context too.
Hey, 0.
Oh, there we go.
Okay.
Now let's run the test again. Let's see if this.
Yeah, it's gotten much better.
Is it? I can't. There's too many subtract traces. I can't quite tell, honestly.
Yeah, it didn't get better. First time chat from TNT Master. How's it going? Well, we fixed some. Yeah, we fixed 20 tests.
Simple pointer is broken. That is brilliant.
Yeah. Cannot emit a unary prefix expression of token type 26. Oh no.
What? Interesting. Maybe we should take a look at that next.
Yeah, let's look at simple pointer. First, TNT Master says, I'm doing good. I am glad. What brings you into the stream? I'm glad. I thank you for tuning in. What do we look at? Simple.
What is token type 26?
And why aren't we using token type to string when we print shit like that out?
That is a good question. Yeah, do that. Token type 26 is ampersand. That's not right. Did we forget to return in unary? We forgot to return, didn't we?
I bet you we did.
In address of, yeah, in the first if. It's the very first if. We need to return.
Yeah, that works great. Honestly, no, dereferencing actually is fixed. I'm not even joking.
That's good.
Member access works. Oh,
that's good.
Redef, simple pointer still fails. With a code gen error, looks like, or something.
With a code gen error, interesting. So let's grab simple pointer. This always happens with this L value nonce. I hate L values. Interesting. That's the optimized version, isn't it?
What? No. Oh, it is.
Yeah, only the optimizer prints that warning. So yeah. What do we have here? That the assembly doesn't help, I think. Let's take a look at the IR. It's much shorter. So we're loading that, we're copying that, we're calling bar, passing in that, and then we're loading this again, and we're returning it. Good. And here we're copying to, we're allocating on the stack. We're loading from the thing we just allocated. That's not good. And then we're storing into the pointer. No, we're storing into 6. We're storing into 6. We're storing the whatever 3 is.
Yeah, so that's, we load a pointer from the parameter. Yeah.
No, loading in 5 is not the parameter. 5 is the local variable, which we're loading from for some reason. That's not right.
We're loading from bar here. This is the actual first operation, right?
We're in bar. That's in bar.
Was that where we were looking? I thought we were in main.
I'm not in main. I'm in bar.
We're in bar. Okay, so in bar.
We're loading 5. That's not right.
Why is there a stack? What's happening? Why are we allocating?
That's for the variable. That's fine. We need to allocate the variable. That's the
Parameter?
probably in. I know where there's one place where we haven't checked in CodeGen, and I mean the function called CodeGen. I think it's called CodeGen, like all the way at the bottom. Like
In CodeGen.c?
The function called CodeGen. Yeah, in here somewhere where we emit the, or it's maybe in CodeGen function. I think it's CodeGen function actually.
And what's the problem?
We are emitting. We are here somewhere. Yeah. Here, see, we still need to set s below that, creating static references. We need to set s decal address in here because this is where we create local variables for parameters. And I think we're not done yet. Let's look if there's more here.
Oh, that little hack. That's right.
Yeah. Not just here, that too. And I think that's it. That's the param decals, CodeGen expression. Yeah, I think that's it.
Hey.
Yeah, and actually go back to that because there's something wrong. We don't want to do CodeGen expression. We want to do CodeGen L value. Not here. We do want to
like
make
of the body.
but in the loop here, we want to do CodeGen L value probably.
Because the decal needs the decal address.
Yes.
Which was already kind of happening because CodeGen expert calls CodeGen L value, but this is just stricter.
Yeah.
And more intentional.
Yeah, I see. There's probably still some places where we're using I instead of address, and that's why things are breaking. And
we'll just make it a union.
The fact that we're emitting variables for parameters, I didn't even think of that. Yeah. So yeah, this works.
Looks fine.
Now, let's run the test again, I suppose.
Oh, I'm gonna commit everything.
That's also a good idea. Yeah.
We have some chats I missed. First time chat from Leonhard Euler 23. Is this a project program or an actual program?
I'm not sure what that means, candidly.
I don't know what that means. It's a compiler. Okay. I think Max has the right answer. It's a compiler. Yeah. I'm working on a compiler. Look at that.
That's better.
Way better.
Some things are still scuffed, but that's better.
I'm just gonna stage everything. Say CodeGen. What have I done?
What have you done?
Bug fixes.
What have we done? Bug fixes, I suppose. Yeah.
All around.
Mostly around L values, but yes.
That's true. Beautiful stuff. Okay. What do we have now? This stuff.
What is shadow.int?
It's shadowing.
Yeah, but why is it failing? Oh, it's probably, I see.
Well, clearly integer is not a type.
Damn it. Wait, what? Of incomplete type, what line is this? That's line 6. So that is very interesting.
This one has an incomplete type. Are we not checking parent scopes?
We should be. That would be in Sema.
That might be where this is from.
This is like generally just variable declarations, I think, is where we would be checking that.
So, cannot declare. It's not anywhere.
Are you kidding me? Is it in the parser?
I think it is.
Oh my god. It is in the parser. Okay. Validate decal type. Oh yeah, I forgot about that function.
What does this do?
This makes sure that we're not declaring an array of incomplete type or a variable of incomplete type. And it does that of the check what that's called actually.
There's an extra space here.
Yeah.
Just I don't know if that's relevant.
I doubt it.
So
this basically just drills down until it finds something that's not a name type but not an array.
So if it finds a struct,
then it would not be null. That would be fine.
so why would it, how null? It's not an array. It's not a named type. It's just integer.
It's a primitive type. It's just integer. So this just goes through the
So type canonical?
type canonical just returns integer.
Yeah.
Of incomplete type. Where are we searching? We're probably not searching. You know what? Let me break on that perhaps. This is what? This is shadow? How do we suddenly break that though? That is very weird.
It's very odd.
Was that broken already?
So we have validating type integer, and then one of them is incomplete. So let me just see what's base type, right? Now let me print base type. Oops.
Where are we calling this from? Oh, I need to actually set what we're compiling.
Look, I found an issue.
Let me see. Hold on.
No rush.
Validation type integer, base type. No, that is not right.
And look. How is integer a named type? It's being parsed incorrectly.
It is a named type in the parser, but it should always refer to.
So it is a named type. Well, that means that it won't just return integer in ast.c like you said.
I know what the problem with this is in general, and the problem with this is that this check shouldn't be here. It should not be in the parser. It should be in Sandman.
You're right.
Entire function is just out of place.
I mean, we can just get rid of it.
Don't get rid of it. Cut and paste it in the type checker.
I mean,
we still need to check if we're declaring a variable of incomplete type, just not here.
Yeah, but don't we already do that?
No, we don't do that.
Here?
No, it belongs here. Yeah, it should go in
That's
here.
not here. Here.
Yeah, whatever that is. Type, yeah, here.
Okay.
So just take all of this.
It has to do with type resolution, doesn't it?
Yes.
This.
Yeah.
And then first, before the init, I would presume?
Yeah, sure.
Ooh. Whoa.
That's if this is not, if we don't have type inference here. Otherwise, how do we know if it's type inference or not?
Why don't we have type?
You implemented the : syntax. What is the type of a declaration if that's the syntax?
What do you mean?
If we have a : 42, what is the type of the declaration in the parser? Is it just null?
I'm pretty sure it's just null, yeah.
Is it just null? If it is just null, then we need to wrap the entire thing in an if and check that it's not null.
That expression type is not null?
Yeah, all of this check. Actually, yeah, we check for. Actually, yeah.
Shouldn't expression type be being set by this?
We check the. Yeah, wait, hold on. Shouldn't it be set by this? It should be
type
set by
inference
this,
is right here.
No, not declarations. It depends. If we have type inference, then yes. So
we have to do the initializer.
The initializer, yeah.
Yeah.
And then.
What a journey.
So in the initializer, to that initializer, if add an else to that. And if we don't have a type,
so this is right? But this is in an else.
Make it an else if, yeah. Else if we don't have a type, then error cannot do type inference without an initializer or whatever.
So we don't have an init, so we have to do expression declaration dot.
Not a declaration, just
source location. Yeah. And then we can do basically something like this that says type inferenced variable requires must have initializer. I don't know.
Or maybe cannot infer type without an initializer, something like that.
Yeah, I cannot type without
declaration initializer, something like that. Whatever. Yeah.
Yep, we did it.
Cool. So that checks that. So after that, we have a type, and now we can do all of these checks. We strip type this, blah blah, and then error at isn't the thing. Just remove the at exactly. Type isn't the thing. It has to be just expert. We can actually just do expert source location instead.
Yeah, because it's a decal, it'll be clear.
Yeah. And that has to be expert type now.
Should that be expert type or base type? Probably expert type because that's null.
In there, it has to be base type. In there, it can be. It doesn't really matter.
No.
So I wouldn't do the base type source location because that could be somewhere else.
Oh,
So,
I see what you're saying.
okay, the question is, are we ever resolving name types?
Probably not.
Okay,
we're calling validate tecal type everywhere still.
Oh yeah, we need to remove that.
Don't do that.
Good, I know why that's happening. Go to type check. What is it? To here, yeah, and after the init if, yeah, here just do type check type. We need to type check the type after this.
The base type or the expression type?
The expert type, and we can. Oh, it wasn't done yet actually. If that returns false, return false, and make sure that in type check type we're actually handling named types properly.
We are.
Because we might not be. Are we?
Yeah.
Named. No, we're not. We need to resolve the type. See, that's the thing.
So what does that mean?
The T named is a symbol. We need to look it up in its scope. Right?
I don't know how to do that. You
Hold
wrote
on.
that.
Think about that for a second. Because actually, the thing is, are we creating name types anywhere?
Yes.
Except for in the AST, I know we're creating them when we create the AST, we create name types for. But do we actually create them in the parser?
When there's an integer in a nested scope, apparently.
Make type name. We do. We are creating a name type. Good.
Yeah.
We now need to resolve the name type. And what we can do is a name type is a symbol. It has a reference to its scope. So we just need to look at the symbol in that scope by name.
And I don't know how to do that.
So that is scope find symbol.
Okay, that's all I needed.
Scope find symbol for the symbol. In the scope, we look up this name. Yeah, the name. But you probably need to do an as span as always. And we need to recurse, yeah, and with that returns, hopefully that returns a symbol.
What does the symbol mean?
Actually, hold on one sec. That's make type named returns a type. Okay, that's fine, yeah. Hold on one sec. This doesn't make sense. One sec. I need to take a look at this. This is stupid. Scope find or add symbol. This doesn't make sense. Why? I know what the problem is actually.
You said that like 8 times, and then you keep going. Wait, no, it's your mother.
This doesn't make sense. Why would it not find integer? That's the thing. Integer is in the global scope. Why does it not? Oh, because
we're not looking it up. We just added this.
Either me or whoever wrote we were stupid and go to pass type.
Okay, hold on. What do I do with this code that I just wrote? Do I get rid of it? Do I keep it? What's resolved symbol? It's just unused.
Let me think for a second.
You just left me hanging.
Wait, hold on. If we have a name type that's unknown, we need to resolve it later. Look it up in its scope. But wait, let me think I need to think for a second. Okay, one sec.
No one's stopping you.
If we encounter if we encounter some kind of identifier, we don't know what the damn thing is, but we know it's a type based on where it occurs. That is then created as a name type, which is a symbol. It has a reference to its scope. It has a name, but it doesn't have a declaration or anything like that. The value is null.
Which is
Then
exactly
when
what we're
we create
accessing.
type, we find that symbol and assign a name to it if it already exists. So therefore, if there is no type, then that type isn't declared at all. So we don't need this in here. That's done implicitly by how the parser works. We don't need it in here. The problem is somewhere else.
And it's in the parser.
It's in parse type, where instead of scope find or add symbol, we need to find it in all scopes, not just in this scope. So instead of true, that has to be false. And that should work. I hope.
What?
What is that?
I accidentally
Algos
ran the tests.
Interesting. Does that work now?
Well, I don't know. It says 2.
2. Should it?
I don't know. Yeah.
Yes, good. So the problem was that we were only looking up the type in the current scope, but integer is quote unquote declared in the global scope.
So the first thing I asked when I said, "Are we searching all the scopes?" It was
Yeah,
that.
I must admit that. I thought we were because it made no sense why we wouldn't be, but the reason why we weren't is because we want to allow shadowing, right? And right now you can't shadow type declarations the way it is now.
I see. Which we may change eventually, but for now it's fine.
Mm-hmm.
There's still a lot wrong. We did it. We fixed it. We have majorly not fixed the optimized version.
Okay, yeah, that.
But that's just because
could not find register with the script of 0. Okay, we're forgetting about something then.
Well, we never went through register allocation.
That is true. There's probably something scuffed in there.
Yeah.
So especially search for like allocers and static refs.
Yeah, I'm gonna commit to bougie.
Good idea. And actually, so
fix parsing and type checking of decals.
Parse type. Yeah, I think the way because this bug was probably also partly introduced with the fact that we changed the syntax around a lot. I think at some point we had a syntax where this bug wouldn't have happened here. I don't know. Anyway, this was just not correct here.
What isn't?
What? I'm talking about the scope finder add symbol. That
I see that one. That makes a lot of sense. Alloca is what you were talking about?
That and static refs. Just search for anything that seems a bit weird.
So as far as alloca or allocate, I haven't found anything.
Okay, interesting.
Static.
Descriptor of 0, but what are we trying to code gen actually? Can you push? Have you pushed what you have right now already?
Yep.
Okay. What example was that was causing the problem?
Optimized shadow.
Optimized shadow. Oh, I need to rebuild. That would help. Jesus Christ, the warnings.
I don't know why. It seems like allocate, code gen of allocate may access the result of the IR.
It might. Hold on. Member access. That's the wrong thing. Shadow. And that's in tests, not in examples.
Yep.
Optimized. Okay. Register name, which is called by reg name, which is called by emit mem to register, which is called when we're emitting an allocate. Oh, alloc. Interesting, because we're trying to emit into inst result.
How does that make any sense? Because
Um,
allocate doesn't make anything, but it makes a pointer, so it does produce a value.
It produces a value, but I think it's right now it's not. Oh, it produces a value. It does, but hold on. What are we generating? What are we co-generating here? What is the instruct? Oh, it's an instruction. We don't have the node anymore. Damn. What is the IR for this? Hold on.
We're looking at it. It's here.
It's here. 4. is, hold on, branch con. Whoa, where's the, what are we branching on? Excuse me. Where's 3? What happened to that? What are we branching on?
I don't know.
Excuse me? That's not right. That would do it.
So whatever 3 is, that has been optimized away. There's still a
Yes.
pointer to it left over in a conditional branch.
Oh, and hold on, in shadow, so if 1, so 1 is what we're branching on apparently.
And you've optimized it out, it looks like.
Have I? I don't know.
Well,
I
it's
mean, I
not
will
there.
do that eventually. I'm not sure if I have. Where would it even be? It would be in const folding and strength reduction, probably.
Naturally. What
Do
is
we
it?
have a branch anywhere? Branch.
There's no branch here.
Branch. What is it even? It's a con branch. Con
So
branch. Branch condition is what it's called. Branch.
IR replace uses seems suspect.
That's for that's division right now. What you looked at, I think. This is, what even is this? Jump threading. If it's that's not it. No, it's not jump threading. Simplify branches, is that it? No, that's just if the then and the else are the same, then we just make it an unconditional branch. This is for tail call checking, that's not it. This is for reordering blocks, that's not it either. This is jump. I don't know, how does that happen? Well, how is that happening? Interesting. I don't know.
You broke it. I'm just messing with you. It's not that bad.
We're branching on the integer literal, but if we look at the IR for that, the integer literal is just gone. What
I feel
happened?
like debug IR should print before optimization and after.
That makes sense. I mean, we saw before optimization, that didn't help.
I just feel like, yeah, seeing them next to each other. Also, it's different now.
What? What happened? What did you do?
It's gone.
What happened? Did you do something?
I don't think so.
Did you
Let me check.
recompile?
I always have recompiled. That's the same command I'm running.
What?
Oh, now it's back.
Did you really run the same command?
I did. You can, I'm pretty sure. Maybe I'm crazy. Look, it's gone. You don't get leaf unless it's optimized.
Can you, like, further up, I want to see the command you ran here.
Okay.
This one.
The same one as always with dash O and CMake build clean first.
Interesting. That's weird. That doesn't make sense.
Gone.
What?
Looks like UB.
Interesting.
So what have you done? Why are we trying to...
We're branching on 3 and 3 doesn't exist.
But why is 3? What is 3? Why are we branching
3
conditionally?
Probably the integer literal.
So why would a branch, a conditional branch, try and be optimized out?
It's
Would it
not
ever?
optimizing out the branch. We're not doing that yet. What it's doing is the branch is using the integer literal, and for some reason the integer literal is being optimized out.
So there's no uses of this here.
Probably the uses are wrong. You know what? You can go to whatever and turn on debug uses.
That's where I was headed. It's gonna be rough.
It's always horrible if you now have to use the. Oh yeah, some macros are still uppercase. We need to rename those.
What have you done? Where?
It's in all. Just search for all. Yeah, that.
Oh my god.
Vector for each. It's just for each pointer now, I think. Actually.
You're right.
Yeah. Any more? We'll
How is it?
So what the hell is it doing? 0, 0. That is brilliant. What? That doesn't make any sense at all.
They're all 0.
Yeah, that doesn't make sense. What is happening here?
Your IR. It's crashing in on itself.
Is it not setting the IDs properly somehow before it tries to print them?
I mean, it definitely is. Unless you, I mean, I haven't touched that code in a long time. Here you go.
I don't know what's going on there.
Replacing uses of 0 with 0. Replacing uses of 0 and 0 with 0.
That's very awful.
Replacing use of 5 and 0. Replacing uses of 6 with 5. Replacing uses of 6 and 0 with 5.
So interestingly, if I run it on my system, I still get the ice, but the interliteral is actually there.
What is?
The interliteral is there. I can try and pull it again. Did I not recompile? I did. So if I run it, the interliteral, I can't talk to it. The
Is it optimized?
It is optimized, yes.
So you have an integer literal in here.
Yes, it is still there.
Well, I don't.
An immediate one. That's there.
Lazy says, so the fun compiler is a name now. Nice. Yes, it's called Intercept, the language. It is named. This is definitely a problem. So when are IDs set? We used to have femit set IDs. Have you touched that? Where is that? They used to be here.
I'm not sure, possibly.
Because we used to set the ID of each instruction as we printed it. But it's no longer here. Naturally. It's only an IRF emit.
I would do it. So we need to set the IDs before we print them.
But we don't have the context anywhere else, so that's not really doable.
We do have the context in intermediate representation.c where we print them, right?
Well, that's what. Are you? This is what I just.
Oh, you are there. Okay.
Yeah. So there's IRF emit. Here's IR set IDs with the context.
Which is called from function, which is called from, where is that called from? IR emit, there we go. Which calls IR set IDs, so that should be right.
Yeah, but it's not, so. Why would the list of users not be set in IR set IDs?
That's very weird, I don't know. Because the instructions aren't inserted in the IR, that's the only way that would happen if they're not inserted in a block anywhere.
Well, that makes a lot of sense because that's kind of the issue we're having here, where there's not an immediate inserted in the block anymore.
Why is it not in the block?
Well, that's what we're trying to figure out.
Are you creating instructions manually anywhere and not inserting them? Is that happening anywhere?
Yep. Last night I stayed up all night and wrote a bunch of code that does that. No.
I think I saw something in cogem.c that looked a bit weird earlier.
Where?
Let me try and find that.
Because we pretty much never create IR instructions. We use the IR functions, or we...
Yes. What is an IR lit integer? And why is it being created manually in cogem.c?
We did that together. So if you don't remember, when we implemented initializers that actually work, then the IR needs instructions that can serve as just holding an integer that is known at compile time. They're not inserted into the
So that's a constant expression. That makes sense. I see. That's just for initializers, though.
Yep, and then in the back end, it's just handled in initializers.
I see. So in here as well for literals.
See? It's a no-op.
Static variables, I see. Yeah, that makes sense.
It's just for initializers. Because we need to pass the data somehow.
That's weird. So what's happening here? What are we trying to emit, actually? Let me check that. Oh, it's wrong here. Shadow and optimized. So we're attempting to emit. Yeah, we're attempting to emit another alloca where the result is 0. We already figured that. Wait, was the alloca in the hold on. In the optimized version, Where's there? And there is an alloca there.
What are you asking? Are you asking me?
Yes.
Okay, in the optimized
So,
version, there is an alaka
yeah,
in
there
basic
we go.
block
Why
2.
is this alloca is not assigned a register, and we're trying to emit that into a register, and that's not working.
Okay.
Why is that not being assigned a register? Is it because it's not used anywhere?
Well, yeah, it's used by 0, which I presume
Yeah,
is...
well, that's not helpful. You, because 0 doesn't indicates invalid instruction, so
Yep.
how does the register allocator handle? There is an is value in there somewhere, isn't there? Needs register, that's what it is. And
That's in
allocators are
register.
only if they're actually used. That
Yep.
makes sense. So what we need to, okay, I see. This is an interesting one because we are trying, the register allocator checks if it's used, and if it isn't used, it doesn't allocate the register. We're not doing the same check in intermediate representation. No, sorry, in the x86-64 backend. We need to do that too. We need to do that there too.
But shouldn't
But
that not... If we're optimizing, that should be removed by DCE, and the backend should never see it.
If it gets to the register allocator, then it's too late for that.
What do you
Should be
mean?
before register allocations. If the register allocator sees it and doesn't, then yeah. If it gets to the register allocator, then we need to deal with it somehow.
Okay.
So I guess
Isn't this you're trying to fix the... If we just like return true here, that's not the right thing to do. We need to go fix the use of allocate not being set properly.
Is it okay? Hold on. Is it no? The problem is not that it's. Is it used anyway? It isn't used, is it? It isn't used.
What?
It isn't used. Yeah, I don't know what that users list is, but in the instructions that are there, it isn't used anywhere.
Okay, I would agree with that. So why isn't DCE removing it?
I don't know. It's not perfect.
It's clearly not perfect.
Can't rely on DC to eliminate everything that doesn't have a use. Like these two optimizations are not linked. We still might end up with an alloca that is unused.
Why? How? Why would DCE not remove it?
I don't know why, but even if that happens, we need to make sure that it doesn't break the backend.
Why? That's malformed.
Sure, then fix it in DC if you want to, if you can figure out how. But all I'm saying is that it can be fixed in x86-64. Oh, because it has side effects, maybe.
So what is if not users.size and not has side effects?
And a locker doesn't have
Should this be
side
or?
effects if it's not used. Is it set to have side effects? That wouldn't.
What is has side effects?
Is
yes.
Yeah, so give that. Yeah.
Doesn't
actually
it does have side effects though?
It doesn't. Does it really? And the locker itself doesn't have side effects. Actually, only if it's used.
What is side effects in this context exactly?
So side effects basically means essentially it's the opposite of a function being pure. So if side effects means if an instruction has side effects means you cannot remove it without changing the semantics of the program. If you can remove an instruction
I have a question.
Yeah.
The stack pointer is altered by allocate. Is that a side effect?
If we allowed accessing the stack pointer somehow, then yes, which we don't.
Okay, so. Yeah, fuck that. So it goes in false.
Yes, it goes in false.
And then we get the wrong answer.
The wrong answer, really? What should it be?
2.
2? Should it be 2? It should be 2.
Yeah, remember this is.
It should, and that is interesting.
A test. Yeah.
It should be 2. Hold on. Where is that test?
Shadow.int?
Yeah. I need to just too many folders. It should be 2.
Yeah.
That is right. It should be 2. That's
But
interesting.
there's some invalid analyzation going on because A is set to 3 and it goes, oh, A here must be 3, which doesn't make any
Yeah, that's
sense.
not right. So,
So
it's finding the wrong A somehow, perhaps.
yeah,
What?
that would
Okay,
be in
that would do it.
const folding, question mark? Where would that be?
No, that can't
Mem
be
to
it because
reg?
those are 2 completely different variables. It doesn't matter that they're both named A.
Also, somehow this made immediate 1 come back.
Interesting. Can you do? Hold on. Let me take a look at that. If 1,
Let me
we're
debug
branching to
this.
2. You're going too fast.
I didn't know you were looking at my screen. I'm sorry.
So immediate 1, that is always true. Sure. So we're always branching to 2. Well, we're moving 3 into 4 into register 4, or into register 1, which we're returning. So based on this IR that I'm seeing here, it should return 3.
Well, no, yeah. No, duh.
It is returning 3. Okay, the IR is right, so we're generating the wrong IR.
Yes.
Okay. That is interesting.
Yes, replacing uses of 0 with 0.
Brilliant. Yeah, we're not setting.
See, printing before optimization would really be great. Let me see if I can do that.
Sure, we can do that. That should be in here.
This is annoying.
Yeah. But yeah, that.
Why do we exit 0 when we debug the IR?
Because it's better. That's easier that way.
In what way?
Oh, if we're exiting with 0, it's never being recompiled. Maybe we're getting 3 because of some.
Exactly. I was like, this isn't a good thing. It's hidden. It's unexpected.
What I do is I don't do this. I print the IR or I try to run that. I never do both, really. So I'd never have this problem.
We're still only printing.
Oh, I know why I don't have this problem, because I don't do everything in one command. I run the compiler, that's one command, and then I always do gcc code.s and a.out, whatever. I always do it that way, so I never have that problem.
Why is it only printed once?
Why is what only printed once? Oh, interesting. Hold on, what?
It's like optimize is exiting or something. It doesn't make any sense.
It doesn't. What the hell is going on? Hold on.
There's no errors. We're making int c.
What you have or something, or what do we? It's not that many changes.
What did you say? You cut out.
Oh, can you push what you have? Is it, how many changes is it?
It's nothing. Yeah.
Yeah.
So
it's just all of that.
I'm just gonna do this.
I'm gonna get a glass of water real quick. Be right back.
Oh, coolio. This is going to be minor. We'll just call this bug fix and say allocate has no side effects. Because that's really the biggest change here. All this other stuff is just nonsense. It's not really needed. Am I crazy? I still don't know why this isn't being printed. If debug IR and see, what is code gen only? What does that even mean? I didn't write this. It doesn't exist. Okay. Why is code gen only? Okay, why would we require that to debug the IR? What? Okay, well that helps a lot. It's printed out 3 times now. Anyone want to explain that one? So just to be clear, was I wrong? Was it not printed out 3 times and I just saw what looked like 3? No, that's for sure 3.
You figured out how to print it. What was the problem? I wasn't printing it.
You stupid. What is code gen only? Why are you checking for this to debug the IR?
Probably to Interesting. That's set if you.
If
Why
you
was it
pass cogen only.
cogen only?
It's like,
Interesting.
why is when
When
debug,
debug IR is enabled, dump IR after cogen.
what is, why, when else? What?
I have no idea what that's for, honestly.
Okay.
I'm not sure when I added that anymore, and I don't know why.
You slipped that in one of the 1,000-line commits.
Yeah. I sometimes add options because they help, and apparently sometimes they don't, or they stop helping at some point.
Okay, another question then. Why is it now printed 3 times?
Why is it now printed three times? It's probably printing it somewhere else too. Either in the register allocator or in cogen emit. Thinking cogen emit, perhaps.
You think in cogen emit?
Or in the register allocator. I'm not
Where's
sure.
cogen emit?
It's in
The very
some
top.
yeah. No, I don't know where. Somewhere and in here, yeah.
This is all it does.
In cogen emit x64, the actual implementation of that. Okay.
There it
Here,
is. After
I don't need
register allocation. Okay.
after register allocation.
That makes sense. Okay, this is fine. This is good then.
Okay.
Before register allocation, after register allocation, before optimization.
Didn't you say there was a 2 in there?
A 2?
Oh, I see. The 2 is in the initializer of a static variable, and the variable is optimized out entirely. Interesting.
There you go. I guess that would be it. When does that like what pass is doing that?
I might know why. Perhaps if the variable is the exit code, meaning it's only quote unquote used by the root, then perhaps it's not marked as used. So the root needs to mark the return value as used.
When after cogen?
In cogen, when we emit the root, I think. That might be it. It's IR return, which should actually use it. No, actually, if the last expression doesn't return anything, return 0. Otherwise, we need to return something. But that's actually, wait, hold on. We emit everything that isn't a function. So yeah,
Because if it's already closed.
If it's closed, if not, it's not closed. So inside that if. Oh, I see. Because hold on, does this make sense? What is going on here?
What do you mean?
Oh, we returned the last one actually. We return vector back arrow IR. And since that's an IR return, that should set it as used, right?
I don't know. We'd have to check cogen intermediate representation, IR return. If return value mark used.
Yeah, if you're returning void, then not obviously. But yeah, if we have a return value, then yeah, that seems right.
So if this is null because it's in address instead of IR, and we've happened to cogen an L value, could that be it?
Yeah, but the thing is, we're calling
an L value.
Expression here, and when cogen expression encounters
But we're never calling cogen express. I guess we are on the root.
We are on the root. So actually, hold on, this isn't.
See,
this is weird.
It's on the last child, so we are calling cogen expression.
In the root here, right here, where it says no declaration, no. Oh, we are loading there actually. So we are cogening that, but can you find node variable declaration inside of cogen expression?
Yes. A variable reference.
I mean variable reference, yeah.
That's the same as up there.
Okay. That is interesting.
This is the same as up there, isn't it?
Mm-hmm. I think so, actually.
Yeah. So we can just.
It is the same. Hold on. What are we returning from this? What's the tree?
What?
The last thing is a var, so that's a variable. It is a variable reference that we are emitting, a reference to a global variable, or to a static variable. So we should be loading from that and returning that.
So, which we're doing in the unoptimized version.
Mhm.
But in the optimized version, we somehow are under the impression that this alloc A and this ref A are the same thing.
Yeah, that's. I
Doesn't
think
make
it's just a coincidence because if you rename the inner variable to b, like copy the, I don't know, rename the inner variable to b,
and see what happens.
that fixes it, I'll be amazed.
It's still 3.
Yeah. So we're thinking a variable is something, we're picking the wrong variable. So it's not the fact that they're both called A is irrelevant here,
Yes.
as it should be. But something isn't going right about this. Hold on. All right, here we're replacing. Well, this is already operating on the level of stores, so here we no longer care about address and IR, I think. Let's scroll down a bit, maybe we'll see.
So here's an
something
IR store, an IR load.
Mm-hmm. Below that, there's another loop.
Oh, to actually change everything.
Uh-huh.
Which just says for each of the loads.
It doesn't. Yeah, because here we're no longer operating on nodes. We don't have IR and address anymore. We're operating in what's inside of these instructions.
Oh, Jesus. Okay, sorry.
Mhm.
That's an Amber Alert.
I know that's audible. That's like, because this is from. Did we have register allocation back then? Even yeah, we did. But this is from like all way back when we didn't even really have global variables. So this
Right.
just finds all variables in main.
So this finds all variables in main, right?
Mm-hmm.
And it just says string equal.
So what this does essentially is it deletes all variables that are only stored into but never loaded and whose address is never taken.
But it's somewhere in here, it's the wrong thing.
Possibly.
Because these are not the same.
Hmm.
And it has nothing to do with shadowing.
No. Funnily enough, it doesn't.
Okay, well, let's...
If you rename the inner variable to b, it's still going to be wrong.
Yes, and it was. We did test that.
Mm-hmm.
I'm now curious. What breaks?
What else breaks? That's maybe an indicator. That is true.
those numbers went up.
How did adding L values break things this badly?
Did you think it would go better?
Yes.
I didn't.
A lot.
It's hard to even talk about.
For now, are there any things that are broken that aren't optimized? Because I think I haven't touched optimization in a while. So it might very well be the case that a lot of the things in there are still operating under assumptions that simply are not true anymore.
So let's look for non-optimized.
Like look through it and fix a few things. So is there anything that isn't optimized but still broken, and that maybe doesn't have anything to do with overload?
Local arrays.
Local arrays.
I don't know what this means.
That's interesting. Unhandled variable reference. What? Where's that? Not in here. Oh, in the subscript. Oh, well, what is this? This is
Local arrays.
local arrays.
Hold on. Oh my god.
What is an IR instruction kind 2?
That's a good question.
I hate this. I still don't get
What are the instruction kinds?
why can't we just define a regular enum?
What order are they defined in? Is it
It's this.
this thing?
Because
All
you've done this stupid a million macro magics just to define an enum.
Types.
So it's
All IR
load.
instruction types. It's the 2 you said. It's a
Yep,
load.
it's load.
Yes. It's a load. It's because are we
What?
calling cogent expression on the left-hand side? On the left-hand side.
Of what? When?
Left-hand side of the thing.
The binary. So hold on. This is a binary expression. It's a subscript. We're having a subscript of a variable reference. So you're saying we need to cogen the left-hand side.
Oh, what we probably need to do here is just
Cogen L value.
Cogen L value and offset because it's a pointer add, right?
Yeah.
Hold on. What can we subscript? We should be asking that. What can we subscript?
A variable reference and a string literal.
A string literal is that something special in the IR game?
It's not. It's a literal with a token type of string, which is how you implemented numbers. So I did the same thing.
Strings. Yeah, I suppose that makes. But a string is just an array, right? So it should just be treated like an array.
Sure. That'd be. I mean, it is an array.
Mm-hmm.
This is a kind. This is a node kind.
Yeah, I
not
see,
a type.
But if we're emitting a subscript, let's consider what a subscript does.
Well, I know what it does. It takes the left-hand side, right?
Mm-hmm.
And then what it will do is it will scale the right-hand side based on the type of the pointer or array that it's subscripting on the left-hand side. And then it'll add that and return the address as a value.
So it can subscript arrays or pointers.
Yep. Those are the types we can subscript.
So if the left-hand side is a pointer type, we can just emit it. So just cogen expression, the left-hand side, and then perform the pointer arithmetic on it, irrespective of how that pointer is obtained.
So even though we never use left-hand side IR or left-hand side address, we still need to do that?
What?
So we never have a... basically, the left-hand side, we never access it. Like, we're not doing left-hand side dereference of it, are we? You know what I mean? We're not using, like, left-hand side IR or left-hand side address. So why would we need to cogen it?
We're doing that inside that if here.
We are doing that here, but after we cogen the expression. So everything should be fine here, right? There's some stuff in chat. Leonhard Euler 23, maybe a silly question, but could you get a debugger working? That's too vague of a question to answer. I can get a debugger working just fine. I can go into a terminal and type GDB and it'll work. So there you go. I don't know what you're asking. Yep, it works. GDB.
I just noticed something.
Okay, Max from chat says he pastes some code and then he says it doesn't work.
Well, it says integer.
That's one thing, but that's not the major thing here. The major thing would be that b or equals integer. This is an assignment operator. B is not an existing variable, and there's already a bug, an issue opened about that on the repo, where if you use a variable before it's defined, the compiler does not issue a warning, it just silently exits, and it's very annoying. So yeah, what you're describing is a bug that has already been found, and it's the correct syntax would be b is an integer, and then it'd be more efficient to just use a static initializer. B is an integer equal to 10, and then return b. So it's both syntax errors and a typo, and a bit of a misuse of the assignment operator. Also an existing known bug occurring, so that's a classic.
Yeah, I just noticed something while you were describing that, and that's line 452. That is sus. This IR at the end is very sus, because that should be addressed, I think.
What is
because
this?
we're accessing the var, and that's the decal, and the decal doesn't have IR, it has address. So this is right. We don't need to admit it, but we need to access the right thing.
You are probably correct there.
It's just so many places where we, Jesus fucking Christ. That just worked. Okay, good.
There you go.
There's so many goddamn places where we were using IR under the assumption that it was an address, and now it's no longer an address. So
that's right. Leonhard Euler 23. I meant getting a debugger to debug the compiler. Yeah, that's doable. I don't think it would help today.
That's what I was doing earlier in C-line. I was debugging it with in C-line.
And there you go. He found it helpful. I don't think I would have found any use in that. It would have taken more time and not learned anything.
Where we were segfaulting.
Yeah. Exactly. That because yeah, we were just getting the segfault. So I might have opened Visual Studio if I wanted to debug that, but it's really it doesn't help me in my development process most of the time. I'm going to be honest. I just spend time fucking with the debugger, and then it's like, well, I spent 2 hours and now I can read that stack address and it's the right thing, so it's not that. Oh well. It's not worth it.
I mean, it depends. Sometimes I would disagree, because the debugger can be very helpful for certain things, like finding out just where, if you just get a segfault, and then you can use the debugger to find out why you're segfaulting, for instance.
That's very true.
If you really need to see like what the state of the parser is, instead of printing everything out, you can just look at it in memory. So, but it doesn't always help. That is true.
We did it. Okay, we fixed local arrays. Let's do the tests.
Arrays progress. So where we at now?
We're gonna let that run. I'll do a commit to commit. We removed that codegen only stuff.
Oh yeah, sure. I'm not sure what that's for, honestly. I know I added it, but I'm not sure what that's for.
Okay, so we'll put that on itself. I'm just gonna say remove codegen only. And then fix variable references. Is that what we did?
We fixed array subscripting, I think, is what we fixed.
That's right. Codegen fix array subscripting using IR instead of address. That's a little cursed. Okay, I've done it. We can check out the tests. Hey, the numbers went down.
Very good. It was a shadow. We didn't. Never mind. Anyway.
Not the optimist. Yeah. Overload return value is very unhappy. That's just because of casting.
Oh, casting.
We can probably undo this.
That one is an easy one. That's in
type checker.
Type checker, where we type check dereferences. We actually do need to allow dereferencing function pointers. So yeah, that's just gonna just go away.
It's kind of a thing of the language that it doesn't allow dereferencing function pointers. So maybe that's a parser level.
No, because what's happening here is we're calling a function pointer, and if you go to Semma to where calls
it replaces it.
Yes, it replaces. You can check that out if you go to the type checking for call expressions. On line 954. 956, it makes a unary expression that is a dereference.
Yes.
That's how it loads it.
Which we should probably, what I was mentioning, this is correct, which means that we do need to allow on the AST level dereferencing of function pointers. But in the parser, if we disallow dereferencing of function pointers, then it'll keep the current. You shouldn't be able to do like at function pointer equals. You know what I mean?
Yeah, but the thing is, we don't know that it's a function pointer until we've passed the entire thing.
Like until we've parsed the entire program? What is thing?
Yeah.
Okay, so you're saying that we need to resolve the function, and to do that, we need to get to the end of the program.
So we'll just allow that for now, and if you really want to dereference a function pointer, then just, I don't know what the use for that is, because
it doesn't make any sense.
With the returned function, the only thing that you can do to a function is call it. You can't assign it to anything. I suppose you can dereference it and then pass it as a variable, but nah. So you just don't do that, I suppose. Can you actually dereference a function pointer in C? I have no idea. Let's see.
I believe you can.
If I go to root and just to print f, that returns the function pointer. But if I dereference that, yeah, you can dereference a function pointer in C++. It just doesn't do anything. Like you can put 20 stars before printf and it just gives you back printf. It doesn't care.
I see.
So
one thing we should check out. I just noticed.
What did you notice?
Downwards funarg is broken.
Downwards funarg is segfaulting. That's not nice.
Well, the actual program being run, yeah. A.exe. So downwards. I gotta go soon. I'm gonna just ignore the time. So downwards funarg, we have a whole bunch of issues.
Jesus Christ, what's all of this? Oh my god.
Yeah, we're printing.
That's way too much IR.
It could be.
Printing 3 times, that's too much. Oh god.
So this is the first unoptimized. Are we optimizing?
By the way, we should probably only print it twice if we're actually optimizing.
That's true. We can do that quick. So we should just do this.
Mm-hmm. Oh yeah, that's a good idea.
Blink. Okay, that's much better.
That is better.
How many times do we have it now? 1, 2. Okay.
We just have 3 functions, so that's why it's such a mess. So let's do 69 looks fine to me.
Yes. Foo. What is foo supposed to do?
Foo calls it, I think, right? Foo calls is past 69 and then calls it, right?
Yes. Just calls int.
Mm-hmm.
The parameter.
So the parameter is a function pointer. It allocates a pointer to a function point. That makes sense.
Yes.
It stores into that. It stores the thing. Good. It then loads it back.
Hold on.
It then loads
oh, that's a copy. Okay.
a function and calls it. Is that right? I think
yes.
So because... yeah. Because pointer to a function contains the address, so we need to load the address and then call the address. That makes sense. Also, I think these parents are a bit misplaced. Oh, that's because it doesn't take arguments. That's why. I see. That's why. That makes sense. Never mind.
It is confusing though.
Then we copy that return. So the problem is probably in main. Ref 69, and we call foo.
What is this ref? This isn't .ref. What is this?
That's a function reference probably, which we
Okay.
don't see too often. That's why it's that. It should also be dot. I mean, it's green, so that at least we know it's a function. See, syntax highlighting. It's green.
The IR looks right.
It does.
So it's the code gen.
Is it right though? I'm not sure. Let's take a look at what the assembly is doing. That is a good idea. So we load the address of 69.
Then just call foo.
With into RTX. That is fine.
Genius.
Yeah.
Genius level.
What is this? That's brilliant. I love move RX into RTX and move.
It's very good.
Oh my god.
So RCX
anyway,
contains the proper thing.
Main looks right. Main looks right.
Is it supposed to be rip addressed?
Yeah, it's rip. Yeah, because otherwise it would be position dependent code.
So when we jump or call, should that be the same thing?
No, the call can be direct.
Okay.
The call can be direct. But
69 just returns 69.
Yeah, that looks fine. So foo, it's
so we
that's
haven't
the function pointer.
move RCX into racks, load the address.
That's the stack variable. We're
Move.
storing the pointer into that. We're loading it back into REX.
Why are we loading this?
That's a layer. We are computing the address of the local variable and storing it in RCX.
When is RCX used?
It isn't.
That's
just
a bit of a problem. Okay.
That's that is not right. That we don't need to do that, but that's not the problem here. Fortunately.
You're correct. Yeah.
Problem is the 2 lines below that where we are dereferencing the goddamn function pointer.
So we move 0 racks into racks.
Yeah, but racks is the function point. Actually, no. Hold on. We are loading. We are moving instead of.
No, this is. Hold on.
I think it's trying to
we have a function. We have.
I see what it is now. It's loading.
He likes to talk.
Yeah. It's loading the function. It's trying to dereference what's at the start of. Yeah, I see. That makes sense. So instead of jumping to the function, it's trying to treat the first 8 bytes of that address as a pointer to a function, and trying to jump to that. So what it's doing with this move 0 racks to racks, on the line before that, we'll move. Okay, did you already notice something?
I think I might know what it is.
What is it?
Well, didn't we just go through that whole thing of like, this is how a function pointer adds a dereference, and this looks like an extra dereference being added?
I now know why I put that check in there, didn't? Was that check? Oh my god!
I don't remember where that was.
It wasn't where we'd cogent unit expressions.
There's token at.
That check was necessary. Are you kidding me? I didn't. I added that check when I remember. Yeah, check if it's a function pointer, and if it isn't, don't load it.
Where did we change that? So if it's, by the way, so this just, we have to do expression type kind pointer.
No, not expression type. That's this is a unary dereference. If expression unary value kind, unary value type kind. If that's a pointer and whose pointee is a function. Copy the entire thing. Horrible, as always. Kind. If the kind of that is a function, then just set the value to the value of that without loading it. Otherwise load. I can't believe it that, the thing is, what you need to know about this check is I remember when I wrote it, I thought this is never gonna come up. This is just
just in case, and apparently it wasn't.
And you're doubting yourself ruined us.
I can't believe that check actually makes sense. Like, Jesus Christ. Oh my God.
So why are we not catching incompletes anymore? That's something that's worrying.
Interesting.
This is looking much better though.
So it's 9 and 8. Okay, so it's just shadow that's failing now. That wasn't earlier. Which is probably an optimization problem.
Yes. Or a use problem, because everything is used by 0.
Oh, stuff. That's not right.
I'll have to look into that.
Yeah.
If I can stay up all night and do something.
It might very well be. I'm not sure if, because we changed how static variables work, I'm not sure if, because static variables aren't inside of a block, just the references, so I'm not sure if the references are being assigned. Does that make sense? I don't think it does, but anyway. Something isn't being assigned IDs for some reason. And typically the thing is, after optimization, if you end up with a bunch of zeros, that's because we forgot to replace users, because that means we've removed some instructions, but we haven't replaced their users, which should not really happen. But if it happens before optimizations, then that doesn't make any sense at all.
So when we remove here without a replace use, is that an issue?
Well, yeah, if we were to remove an instruction that is still being used, and that's a horrible problem. But IR remove checks for that. If you go to IR remove,
I see. Whereas probably
intermediate representation.c. If you go to IR remove, it will scream violently if it's still in use.
Okay, and it's not.
Yeah.
So we're not removing something that's likely hasn't been replaced.
Yeah.
But that was the issue that would cause this bug.
That is
one
possibility that might be causing this, yeah. Or at least it was before I added that check, I suppose.
This is a mess.
Really? Yeah, this can, however, be optimized, or rather rewritten to be a lot better now, I think.
That
because
would
now
be
we
helpful.
have a proper differentiation between static and local variables and all of that, so it will be a lot nicer.
I'm excited.
Yeah. I really, since we've been adding so many new things now, I think it's really time that I sat down and worked on the optimizer a bit.
Yes, it should be much easier too.
Yeah.
We have a lot more data.
Mm-hmm.
So when it says errored, what does that mean? Why does it print it twice?
Errored and failed. So failed means typically the program executed correctly, but the output or exit code was wrong. Errored means that yeah, you see that. Do you see the assembler messages there? Errored means it failed to compile. 3 lines below that.
Okay, I see.
No,
here.
Above there.
So these are from.
Yes.
Yes, but they're from this failure?
They're printed before the failed normally, yeah.
Yeah, okay. So errored is probably ice, isn't it?
Errored is ice, yeah, I think so. Or generally just if the compiler exits with a non-zero exit code, which is typically doesn't need to be an ice, I think.
That's true.
Fails to compile.
And this is byte size cannot be. So it's basically we're expecting an error, but we're not getting one. So why aren't incomplete types being checked?
What does incomplete.int do?
This.
Declaring a variable. See, this is what validate decal type used to do. Are we not checking for that anymore in I know why. See, this is why we have type is incomplete and why you're supposed to use that instead. Because void,
instead of what?
if the type is void, then it's not going to be null, but it's still incomplete.
So we need to check with type is incomplete instead of just doing not.
When? Where?
In what we declarations, the no declaration. Here, further no.
That's
What? No,
okay.
this is inside functions. This is somewhere else. This is casts. Here. In below that actually.
Not base type?
Not base type. We have to do if type is incomplete instead of not base type.
Naturally.
Naturally, because void is not null but incomplete.
Okay. Oh, what's gonna happen?
That
It worked.
works.
Not the
Nice.
param though.
Yeah. Ugh. I know why, because we need to do the same check in function declarations.
And that's the other place I removed decal type from.
Yes, probably. So wherever we type check node function, sure, we need to type check. Actually, we don't need to do that in here. We have type check type. Where we type check the function type, we can do it then. Type check type. For each parameter, we also need to check that it's not incomplete.
So when we type check a type, if it's incomplete, we return false?
No. A type can be incomplete, but the function parameters can't be incomplete, is what I'm saying. You can't declare a function parameter that's an incomplete type. A type, you can have incomplete types in here, that's fine. But function parameters can't be incomplete.
Okay. We're going for it.
Now I hope we're actually calling type check type for functions.
We are.
Would you look at that?
Hey.
Nice.
Check for incomplete types. Hey. I think we might have even fixed some tests that weren't running before.
That's good. Oh, and also, by the way, something's a minor thing that doesn't really matter, but what I wanted to mention is we could rename typechecker.c and typechecker.h to semma.c and semma.h, since it's a bit more than just type checking.
Yeah, I'm okay with a bit of a misnomer, I think.
Especially since we keep referring to it as such.
Yes,
That's
and
why.
it's in all the documentation. Saying semma, it makes people learn a new word. Whereas type checker, they can deduce it.
Nice. I like learning new words.
Yeah, you are not people. People do not like learning new words. It's sad, but it's true. Lens has spoken. Dun dun. I hear like the Law and Order. So good. That's a good example of me not being able to communicate what I'm thinking.
You are not people.
You are not people.
Oh dear.
3/5.
Oh yeah, I guess we can merge this now. It's like mostly fixed. We have fewer failing tests than before, so.
I want to actually. So what fails? We have shadow, return value.
Overload return value is because of a cast, apparently, so that's unrelated.
Yeah, that's been happening for a long time, I'm sure.
Okay, that's ref in call. I have no idea what that is.
This has happened forever, even before.
Okay, yeah,
it's the same bug as the the optimization bug for shadow.
Overload block for some reason. That is interesting.
I think that may just be left over. I don't know.
No idea what overload block is. What is that? Oh, Jesus Christ. What in the world is that?
What is this?
That's it. Oh, it returns a function pointer that's getting called. This is a function that returns a function pointer.
Okay, hold on.
Jesus Christ, this is quite something. That's why. Yeah. this needs to, because how we're resolving this needs to like resolve it in a very, very complicated manner, because we need to kind of
Oh,
search up
fuck.
what we need to find the contained function, because this is a return value here. So we need to kind of go up a few blocks. That's what that's in here. This is a very degenerate case of ambiguous overloads.
Yeah, so if you return...
You don't need to skip it, because we still need to fix that at some point, but it's only also one test. We've other tests that are failing, so it's not that bad. If this is just showing up as failing, that's fine.
That's
It's not
true.
that bad. But yeah, this is a very degenerate case of overloading can be hard. Like, look at this. We need to go up block expressions if this is the return value. Ooh. It enables a degenerate case of overload resolution. Yeah, sure.
Perfect.
You know, sometimes when you're working on compilers, you're like stuff like what we were doing before. Okay, L values, whatever. If it's a variable, then we need to actually take the address. Whatever, that seems reasonable. But this is just very stupid.
Yes, it's never going to be used.
It is probably never going to be used. The same thing with how in do you know that in C, if you do A brackets 2, you know, a subscript.
Yeah.
That's just A plus 2 parens dereferenced. So you can do 2 brackets A. You can do this.
Yeah, yes.
Let's see. I recently had to implement something in a C compiler, specifically arrays. And I wrote a comment there that said, technically C also allows for the degenerate case of integer brackets array, but I'm not going to implement that because that's not used outside of compiler unit tests. So, or tests in general. So I didn't bother implementing that, especially since that was a single pass compiler, so that would have been very painful.
Just for a good example, like when we handle our command line arguments, we could also do I offset by argv.
Yeah. Just leave that in there for posterity. Someone will find that and like be very confused.
And honestly, it's not that weird other than you haven't seen it. Because it's like, oh, there's argv, some array, and you want to access the ith element.
Yeah. It's also not that bad here because they're both variables. If it's like, if you look at 2, like if it's number outside, that looks very weird. This just looks incredibly weird.
It does.
This is not that bad, but...
Do we ever do argv0? That'd be perfect. I guess I can just search for argv0. Perfect.
Yeah. Oh, that is brilliant. I like it.
Oh, I even did it wrong.
We could also just do star argv, but nah, that's too... No one... Why would you... Oh, God. Just like... I just realized something. Instead of dereferencing a pointer, you can just write 0 and put the pointer in brackets.
That's a good idea.
Oh my God.
Can you imagine replacing all dereferences?
Yeah. No, that's a declaration. That doesn't work. But
I know, I was waiting. I was like, I still haven't found one.
Yeah, that one works.
So I would have to... Oh, no.
The entire thing, because precedence, yeah. No, yeah. No. You need to take... No, that's the... Wrong precedence.
What did I do?
Subscript is higher precedence than dereference. So you need to wrap argv I, the entire thing, in... Yeah, like that.
What? Okay.
But that's the wrong parens.
Tree sitter is confused.
Yeah, I'd imagine. I can't blame it, honestly.
Did I do this right? So we want to dereference argv at I.
Yes, that's right. So now if you replace the star with a 0 and the parens with brackets, then that works. Yeah, and you don't even need the parens inside.
It's beautiful.
Oh, we can remove the parens even, because the brackets already enclose them. Yeah. Would you look at that? This is peak C, ladies and gentlemen. This is... If anyone ever said C is a sane programming language, show them this.
Yeah.
Show them this.
Oh, that's so good. I kind of want to leave it.
Yeah, let's just leave that in there. Like, oh my God,
it's happening.
Lemnian in chat is very apparently seems to like this idea a lot.
C is insane.
Also, Lens, look at chat. People apparently like the idea.
Beautiful idea. Beautiful. Yes. We're going to rewrite the whole code base with this syntax eventually.
No, we're going to add a lint rule. So when people open PRs, they need to use that syntax.
We'll just disallow the asterisk.
Yes, actually, who needs that damn character anyway?
And we don't... Multiplication is for nerds.
It's for plebs. Who uses that?
It's just repeated addition, clearly.
Yeah, just add a few times.
Because this is really just an AST array of 1, right? If we really want to get technical.
It's at that point, it's not really... It's yeah, that's the horrible thing about arrays. It's not quite the same thing.
That's right.
As I would know because I recently had to implement arrays in C and it was horrible. Passing it, like if you pass an array to a function and you need an array that is passed to a function is still still has an array type, but you need to dereference it differently. If you pass a multidimensional array to a function, for instance, it has you still need the array type, so you can't just make it a pointer, but you need to dereference it differently as opposed if it were a local array. It's horrible. You basically need to implement references because arrays are passed by reference.
That's right.
Basically references. What you need. It's
hey, moving fast. Thank you so much for joining the Discord. I don't know if you're watching, but thank you. Thank you. Yes.
What is the godforsaken print function? Someone in the Discord is saying people can now see the godforsaken print function.
What? Who asked? Where asked?
In code reviewing on the Discord, I just saw someone talking about the godforsaken print function.
Okay, I'm gonna look at it. Oh no.
It's
Yep.
end line 2. Oh my god.
I saw IO stream. I was like, uh-oh.
I didn't even look at the headers.
Oh no. Oh no.
Jeez.
Set width.
This is how you do
fill.
widths. This is C. This is C++. This is like, this is what people like IO streams will tell you that this is sane code. Do you know what set W does? It sets the width of the field. So that's the same as what star 25s in printf. And set fill tells you to use spaces for filling. This is what they tell you. This is quote idiomatic. Idiomatic IO stream code. I mean,
this is terrifying.
Where is that slide from the format lib talk? Hold on. CppCon.
Proof that C++ is the superior language. Oh yeah.
Oh my god, yeah. Where?
Because obviously there's one best language and all the others aren't useful.
There you go.
That's how the world works.
There you go. This is from Victor. Oh my god, he is Ukrainian, so his name is Zverovich. Apparently, it's hard to pronounce, but this is the guy who made format lib, and I'm just gonna post it in here. Just look at this comparison he makes here of IOStream versus printf, and this is the same code. It does the same.
I wonder which one's easier to write.
Yeah.
It's
I wonder which one. Not just easier to write. I wonder which one is easier to understand. I mean, if you look at the bottom code, do you know what this prints at a glance?
4. No, I don't.
You don't. If you look at the code on top,
X.
This is where format strings are nice. You can tell more or less what the structure of what's being printed is.
That's right.
Also, not to mention that printf, which is not a state machine. If you look at the source code, it's like dozens of labels and go-tos everywhere. Printf is 2 to 3 times faster than IO streams, at least. IO streams are not only bad and inconvenient and clumsy, they're also very slow. There's no good reason to use IO streams.
That's very true. Yeah.
Unless you're reading a single line of input from a file, in which case getLine only accepts input file streams. So, but usually you're better off just mapping the entire file. But that's like the one use of IO streams that I've found in the past 2 years or so. Other than that, they're pretty much useless. And that's just because because I couldn't be bothered to write a proper getLine. If in the standard they added a getLine for files, so file pointers, standard IO files, I would never have to use IO streams. And apparently someone wants the notifs role on Discord.
Oh. TNT Master 58, can you give me the notice role in Discord? That's Reese. You just joined. I remember waving to you. Hi, Reese.
In the search bar, if need be.
Beautiful. Relying on Discord search, yeah. It'll work great.
I think you forgot what language this is for a second.
I probably did. What am I doing wrong here?
Arab decals are a bit off. Just saying.
Yeah, they are. Don't worry about that. Okay, how does this look?
Also, be right back, okay?
Coolio. Whoa. Now we can just test this out. TNT Master says, thank you, of course. Of course. So now A is vec2, B is vec2, A dot x equals 34, B dot x equals 35. And then we'll have like B dot A equals 420. Return vec2 add a B dot Y. I'm just curious if this will work. I'm curious how far we've made it into development. Invalid type kind 5. That's in types equal canon, which is in the AST. Where is that? What? Type checker. Oh, so it's like a types equal. Hello? Here it is. That took a while. It's another mutually recursive function. Lemnine says, is that Emacs? All of this is Emacs, yes. TNT Master 58, I think that is. Do you do streams on developing Lenser OS? Yes, I do. Not as often as on the compiler, because the compiler is kind of my main series, but I do OS videos. So what? It said invalid type kind 5? What other kind of type is there? Type struct. Okay. Case type struct. Is that in the that's in the wrong spot? No, it was in the right spot. I'm crazy. Okay. So we want to check if the structs A and B are equal, which means that we have to go through each of the members and compare them. Bop, bop. Okay. For each member, what do we need for each? Type element vector. Type element, so for each member in, this is a struct, so for all of the ones in A, then I guess we could check alignment and byte size to boot. That might be the way to do things. So if A structure dot alignment does not equal B structure alignment, turn false, byte size, and then we may have to compare the layout of each member. And then we're going to say if not, types equal, this is an interesting one. We have to iterate through 2 at once. So you know what I'm probably going to do is just go steal this. And then reason about how to make 2 of these. Element which equals vector. Structure dot members. Okay. So I think a while might be easier. I'm not necessarily sure. Because we already know... Okay, another thing we can count on that would be helpful to know as an invariant is the size of each of these members arrays, or vectors, excuse me. What multi-cursor package are you using, asks Lemnine. I'm using multiple cursors.
So, what are we looking at?
Hold on. Yeah, one sec. So someone asked what multiple cursor package I'm using.
Ah, okay.
So we have to iterate over 2 vectors at once. There's not an easy way to do that, right?
No, you need to use... oh, no, there's no... We don't have zip or anything like that. What... Oh, I see what you're doing. You're deep comparing types, aren't you?
Yep. Because...
Yep. Yeah.
Yeah. So how do I iterate by index? Should I just do it by hand?
Vector for each index, but that doesn't help you here. Actually, yes, there is. There is vector for each index. You can use that. That just gives you the index you need to. Then I use it immediately. So it might be for each index, and that just accepts an index, but that's always a size t, and a vector.
Can I do this?
No, you don't even need to say it's a size t. It knows it's a size t. No, you don't need to declare.
Okay, it's just it names it.
It names it, and then you need to pass it a vector, and it will just make sure that it doesn't go out of bounds for that vector.
Which we've already compared the size so that we know both of them are the same.
Mm-hmm.
So then we can have member
Actually, okay, same number of members. Okay, no, that's fine. That's fine. Yeah, because I was in this. You don't have the problem that I have in Source, because in Source, padding is achieved by inserting character arrays, and there's a reason for that. We don't have the problem here, so sometimes you might end up with different amounts of members, and it's horrible. But we're fine here, so we don't have the problem. So we can just do this. Yeah, types. Well, it's a member, not a type. We need to compare the members manually. We need to, amongst other things, check the member types, but we also need to check their offsets. Because if we ever add some sort of align as qualifier or whatever, then it might just be that the offset is different. So just as a sanity check, I check the offset. And then the only other thing that matters is the type, I think.
I don't think we should require the same name.
If no, we have because this one, I mean, it depends on what you want to... Where even are we? Are we in... I feel like we're in convertible or something, or in type in equals, right?
We're in types equal canon.
Types equal to non-equal. Okay. So this depends on the semantics that you want. I mean, maybe you just talked about this and I wasn't clear when you explained that. But do you want types that are different types that are structurally equivalent to be the same or not?
Yes.
Or rather convertible to one another?
Yeah. These two types should be convertible. Because they're valid layouts.
Okay, and you should be able to treat them the same exactly everywhere.
Yes. Except for the name.
Okay, sure.
if you want to do that, then what you're doing is correct. Yeah.
This makes sense, right? Because then you can pass in a vec2 with a convertible.
Just for extra type safety, I didn't choose. I chose not to do it in source, just in case you want to have two types that are that happen to be structurally identical, but that are different. For instance, a good example, and actually, span and string is not a good example because span is a const char pointer, string is a char pointer, so those are different. But you might end up with two types. I don't think you. Yeah, outside of that. You might, at least my train of thought was that you might at some point end up with two types that sure happen to be structurally unique, but that have completely different semantics and that you wouldn't want to use in the same way, which is why I decided that I wouldn't be doing that. But then again, the thing is, source has tuples, and tuples are implicitly convertible to one another and also implicitly convertible to structs. So it's less of a problem that structs that have the same layout are not convertible to one another. I definitely say that I'm rambling again. I'm sorry.
It's okay.
But one last thing. I definitely say that or agree that anonymous structs should definitely be convertible to one another. That's probably a good idea. It's just that maybe you might not want this for named structs, but I think it's debatable about whether or not that's a good or bad idea.
The invisible bug strikes again. This thing.
What is going on here, actually? Oh, I know what the problem is here. We can fix that.
Why exit?
We can fix that, and it's, I think, at least, where we're looking up variables. Where are we looking up variables, actually?
What does that mean? In the type checker, in the codegen, in the parser, in the...
We're looking up variables. So what if how are we passing variables, perhaps? We're just, hold
It's
on.
an identifier.
It's an identifier, so that would be in pass expression. So if it's by default, okay, if it's a variable, then we make a variable reference. But the thing is, if it doesn't know what it is,
it makes a function reference?
It makes a function. So the question is, if it's okay, if it's not declared, it can't be a variable. That's how this code here works. So it should be impossible to obtain a variable reference to a variable that isn't declared yet. So what's the error exactly that we're getting with the...
No error.
Can you have like a minimal example that isn't the rule 110?
Well, that's not the example here either, but
what is... It's a pretty long one.
We're doing vec2.int is the problem. Look, this. Very simple.
And the error is what? Sorry. What was the error?
There is no error.
We're not getting an error, but wait, is everything fine or not? What's the problem?
It exits with code 2 from type checking. Silently. Look.
What?
That's the same bug, as I said, where it exits silently from here.
I get what you mean now. I see. So the type checker is exiting without printing an error.
Yeah. It's really annoying.
Interesting. Exit 2. Yeah, type checking. That is interesting. So type check expression, something is returning false here. Then without printing a message, just type check type. Actually, I can try and step through this. One sec. What's causing this? Like your vector example is causing this. Is there a test for that? Sorry, I'm jumping all over the place.
There is not a test for this. I just wrote this program as a little... I was seeing if we can make like, vector2 add.
The issue, the thing, the program in the issue.
Yes. This is not a test.
Oh, you just put this in here.
Yes, this is from my Rule 110 thing.
Okay, yeah, that's why I meant Rule 110.
Let's just see.
Suppose you could add that, and also we have another
Yep, same
question in
thing.
chat.
Still doesn't. How did you find this Norseman to help you with your compiler?
Jesus Christ. It's a northern accent, not a Norse accent, okay? At least this is, I think, the first time that someone calls it a Norse accent, I suppose. Because what I've gotten before is that people thought I had a Scottish accent, which I don't. It's not a Scottish accent, okay? It's a northern accent.
I'm from Liverpool. I'm sorry. Liverpool is northern, right? That is up there.
Yeah, that's north. Yeah.
I like how you're laughing. I know I don't. Yeah. I think you just shattered his spirit. But don't worry, he isn't people.
Jesus Christ.
What have I done?
But yes, Liverpool is in the north. You're right about that. That's one way of putting it. My God.
So
It's not like there's a famous northern accent that is from Liverpool or anything.
that's when you like have a weird growth coming out of your knee, right? What do they call it?
What?
Cockney? That's what it is.
Jesus Christ. Christ. You know, Cockney is London. Cockney is a southern accent. That's the opposite of northern.
You know what's weird? I don't see it. Like their pants look normal. He's referring to Lennon.
London.
Lennon.
Which, if you're confused about the pronunciation, by the way, in Old English it was spelled London, L-U-N-D-E-N. The reason why it's spelled with an O now, fun fact, is because it's followed by an N. And in some medieval, I guess, can you really call them fonts if it was handwriting back then? But in medieval handwriting, they had this thing called minims, which is basically just a very short stroke that you find in like an M or an N. Like an N is 2 of them, an M is 3 of them. And if you have a bunch of them next to each other, it becomes very unreadable. So what they did is, straight up, if whenever there was a U before some other letter with minims, like an N or an M, they started spelling it as an O instead. So that's why London is spelled L-O-N-D-O-N and not anymore, at least L-U-N-D-N as it was. Like the O in London, the first O used to be a U. And I know I talk too much. I tend to. If you don't stop me, I will keep talking. Like, feel free to interrupt me if you just see me rambling on again. I tend to do that sometimes.
Listen, I think that is an endearing quality. I truthfully, because I don't talk. And people tell me I'm like awkward and weird because I'll just sit there for 10 minutes and not anything. And I don't like that about myself because I feel like I like shut off from the world. Whereas when you're talking a lot, you are able to like be in the moment and everyone around you is able to also be with you.
No, I will say that I also do that a lot because I don't like interrupting people normally. So
I see.
I just stay silent until they stop talking. If they never stop talking, I don't talk.
That's very respectable as well. Because I'd say somebody who constantly interrupted me, it'd be like, I could talk to them, but I can't have them as a guest on a stream. You know what I mean?
By the way, if you think I talk a lot, no, I've talked to people who would just ramble for half an hour and I just stand there.
Oh God, I'm so sorry.
Me, them, and someone else. It was just me and them. Like they were just talking to me for half an hour. Just with yeah.
This example is now pushed.
Okay, we can take a look at that.
And then I'm also going to update here. Example at...
I just get reset.
Example at vec2.int is...
Also suffering from the same problem.
Yeah. Okay, I have to go in like 5 minutes.
Before I forget, a Liverpool oxen. Jesus Christ.
Oxen.
Liverpool. I don't know. Maybe I was thinking of Oxford for some reason. I don't know. At least that's what came to mind all of a sudden. A Liverpool. Jesus Christ, Liverpool or Liverpudlian, as is the adjective. A Liverpudlian accent is called scouse. That's scouse if you've heard of that before.
I haven't heard of scouse.
Of course not, Jesus.
I love Liverpool oxen. Lemnian says, how did you two meet? And then TNT Master says, how did you two meet again? I went away for a moment and missed the answer for this question. We met right here.
Yes, so essentially, I think I stumbled upon your videos on YouTube because I was searching for, I don't even know what. I don't even know how I found your channel. Probably I was, since I mostly work on compilers, I was probably looking for compiler related stuff.
That would make a lot of sense because pretty much every compiler video has every combination of the word compiler in its tags.
I see.
C compiler, low-level compiler, systems.
Compiler video, how I found you, that I know. And then I was just watching the stream someday, and you were, or I think I clicked on the Twitch link, and you were live at that point, and you were implementing Cogen of div, and then I mentioned the fact that you'd actually need to do sign extension, all of that, and then
Kukato.
it just went from there. I think, yeah. Word quad to octal word or whatever it was.
Yeah.
I was not scouting for compiler talent, okay?
I'm being groomed. I'm like an Olympic athlete. You're my abusive manager.
Oh god, Anyway, what was I doing? I was gonna debug this, I think, right?
You were checking out the example is now pushed in the LVALUES branch.
In examples. See, I got so annoyed by tests and examples that in my compiler, I just moved everything into the test folder because I couldn't stand moving between the two anymore. Everything is now a test.
I hate the examples folder right now.
Can you just move everything into tests? Like
everything that's here, yeah. There are 3 or 4 things here that I would like to keep.
Okay, like rule 110 maybe, sure.
Rule 110. And then another thing I want string literals to be an example so people know how to hello world.
Okay, sure. We could also just make a hello dot int that just prints hello world, or rename that to hello dot int or whatever.
Exactly. I think that's a good idea. And then structs we're still working on, so that's a good example.
Feel free to just also cast is still missing a file extension, and there's gcd.ii in there, which is probably horribly broken.
Yeah, this doesn't work anymore for sure.
Anyway, what was I doing?
Actually work.
Examples.
Vec2.
Vec2, thank you. Vec.
So we have hello world.int and we also have string literals.int. So I don't think we need both of those.
Probably not. Also, do consider if we move all of that into tests, then we have more tests.
I don't know if we do. A lot of this stuff is already in tests.
But more tests. Do you understand? More tests. Even if it's the same thing, it's still more tests. It's a bigger number. Bigger numbers are nice, okay? Unless it's the number of failed tests, which is not nice. But you get what I mean. Examples.
So good.
Vec2.int, not optimized because we're not even going to try that. So somehow the type checker is returning. Where do I even break for this? Here? Jesus Christ, the breakpoint in main. It's come to this. That's like sad. Okay, it does indeed return false. Why? My God. Okay, sure.
Okay, I hope.
Okay, some expression returns false, and which one?
A
binary expression returned false. What binary expressions do we have in vec2 dot?
I do have to run.
Oh, I see.
In like -5 minutes.
Negative 5 minutes.
Yes. Also in chat, we have, you are lucky to have a compiler friend with you. Yes, I am. To find someone who likes the same thing as you. I would agree. That's a large part of what I like about streaming is like, all you guys are awesome and like the same things as me. And I don't have to explain, oh no, a pointer is like this thing. You know what? Don't worry about it. You guys understand me.
I think the problem is what's failing is we are assigning some assignment expression to a member access. So let me see if I can step into that and find which one that is. So it's
alrighty. I am gonna have to say I'm opening up Scratch and putting goodbye, just so you know. That's where I'm at. Okay. Thank you, everybody. How old are you, Len? Says Lemnine. I am 20. Thank you, everybody, so much for watching. I had a great time today. We implemented LVALUES as a complete separate thing in the compiler, and we actually got it to a point where there are less tests failing now than there were when we started. I think there's 6 and 7, right? I don't remember.
6 and 7. I think so, yeah.
Yeah. It sounds right. How long have you been learning programming? 1.5 years. But yeah, thank you everybody so much for watching. I've had a great time, and we actually got stuff done. We did it. There's an off by 1 error in the optimizations too. And TNT Master says, wow, what an efficient stream. Yeah, we definitely, it's not normally this productive. 6-9. Oh, it's perfect. Lemnine says, until we meet again. Until we meet again, Lemnine, thanks for coming out. It was really fun having you in chat. You were so active, and I really appreciate that. TNT Master, it takes me like 2 hours to write like 2 lines of code. Normally, I'm the same way. Currently in... Nix Craig doesn't believe that that's C code.
It's currently in use in the compiler code. No, you missed the chance to say it's production code.
It's prod.
It is.
So good.
Struct type is a type struct, that's fine.
Okay, thank you so much, everybody, for coming out. We had a great old time today. Suraid, I would like to thank him. Be sure to check out the description of the VOD on YouTube for all the links to support everybody that was appearing in the video.
I found the error, by the way.
Oh, he found... What's the error? Is it quick to describe?
Printing a message if the member, if it can't find a struct member. We're just returning false.
So in member access is the bug?
If not member return false, that's the problem. Line 1226. 1226.
Okay, to do. Fix me. Okay.
Somehow I'm gonna do that. You can.
Okay.
You don't even add a to do for that. I'm just gonna do that.
Okay. This is good then.
Like, somehow we both missed that.
It's true. Oh, I can't close Emacs yet.
Rip. Oh, have you pushed everything else though?
Yes. Let me double check. Yep. That's it. Even the tests. Okay.
I could merge this branch already or not?
Yeah, why not?
It's like pretty much done.
Click. Click.
I mean,
I'm not even... Okay, I don't even have time to merge this right here. I'm just going to... I'm going to say... Thank you, everybody. I'm sure everybody's already gone, but thank you, everybody, so much for watching. Check out the links down below. There's YouTube. There's a donate button. There's a button to go donate to Suraid because he's awesome. You should contribute to him. And I believe that's all I have to say. Thanks. That's all my plugs. I've been plugged, and I'm all plugged out. What was that?
Check out the Discord.
What's here? What do I...
Oh no, not you, but the like.
Yes,
chat.
you. Oh, I was like, wait. Yeah, there's a Discord where there's announcements every time I go live. You can join a notifs group and be notified wherever you are, and I'll welcome you when you come in. I'll wave to you. and say hi. So that's always fun. But you can get help with code that you're working on. You can show off in code review. You can say anything and off topic as long as it's legal in your area or not. I don't care. And if you're under 18, just say that you are. And I think we're good to go.
I think so.
Alrighty. Thank you everybody so much for watching. I'll see you on the next one. Bye-bye.
Ta-da.